This right here, you would tell me music scale, right? What if I told you it's how a vortex is working? You're working on a music scale and you really don't realize it. Why? Because the thing is actually pumping when it's in the center of the vortex. So when we create our vortex, right, it creates a pump, just like a Tesla coil. So think of it like this. Say here's my center of my Tesla coil. I'm simply taking the energy. It goes up, it comes down. It goes up, it comes down. It goes up, it comes down. Just like this, right? So now I'm creating a pump, right? I'm creating a pump right here. What happens when you create a pump when you have magnetic fields? Well, you say, well, that's an awful lot like a speaker, isn't it? You simply have a magnetic field with another field that has magnetism pumping, right? Is the sound going to be that great? No. But is it still pumping? Yes. Are you still going to get frequency out of it? Now let's understand it in the correct way. We'll stop sharing that one and I'm going to show you. Let's see if I have the better picture of it. This right here. We've all seen the Russell scale, right? What if I told you it doesn't get created without the pump? The actual frequencies in it, right here, are creating, and you notice the way I drew it before on the board. Drew it in this manner for a reason. They're creating your scale. They say the fifth, the sixth octave, everything's in the size and distance between them. Now you should start to understand this. This is what's coming out of the top and bottom of your vortex. This is the Russell scale. You are now transmitting frequencies out of the core of this thing in that magnetic field. You now have a symphony going on when your coil is running. That's why you're getting all of these things. That's why, depending on where you are on the earth, that's why you get gold, or you'll get copper, or you'll get other things. Okay? They're built based on the way that you're building your ether. You are building it with this thing right here in mind, where you take the core of it and you're making sound come out of it. You're making frequency coming out of it because it pumps. That's the basic understanding of that. There's so much more here than people really realize when they do this kind of stuff. This is how your vortex is working. You're getting scales in it. You're getting understanding. You're getting flows. Okay? This is basically what we're looking at. It's more than one thing. It's all of them combined in one. That's what a lot of people don't understand. I'll just remove this and I'll open it up for everybody. We are creating this scale when we create this field inside of our coil. Now, depending on which coil you have and the geometry of that coil depends on how far it'll go. We know we put a magnet in the center, it'll start to make sound if we do it with a rodent coil. What happens if I take Gerald's coil to this? There's so much geometry going on there. Let me show you something else that you may never have seen. And it's because we don't see it correctly. This person, whoever drew this, started to understand what he was doing. He knew that geometry, when you create a geometry in a coil, you actually start to get tones from it. Okay? Major second, mini third. Okay? Now we're starting to get into between where we need to be. It's getting closer in the way they're understanding this, but they're not quite there yet. You see the lines all converge in the center. Well, the actual diagram should be flipped upside down. The actual thing converges in the center when you hit the center point, but that should be in the center. This would be the portion of the bottom half of what you're creating. If you created two fields, right? Instead of just one. So if I create two coils, I create this, and then I get this center point right here. But it's when you print it the other way, then it creates the vortex and they go outward, and you're still getting the same notes. Again, what happens to these straight lines? They start to swirl in the vortex. That's why ram's horns are important when you want to talk about the Bible. You want to talk about the walls of Jericho, you better talk about the ram's horns, because that's the same swirling effect you're going to get when you talk about these coils. Maybe now everybody can start to put it together. You see a coil wound. You know that the tips of them are creating something, but what are they creating? Okay. Whether it's on the inside or outside, we're still creating that music. That's the understanding there. It has to do with everything. You're not just creating things in one way. You're creating them in multiple ways. That's why it's so important. Guys, you have to understand, it's not supposed to be easy, okay? Not in certain parts. Until you understand it, then everything becomes easy. But the understanding comes first. We build it. Sometimes we find it when we build it. Sometimes you can't know it until you build it. So, in building these things, I could tell you right now, you're getting a symphony out of this thing. You may not be able to hear it, but it is. It's coming out. I can tell you from being 80% deaf. I don't hear most of it, but I know it's right there. It's creating it in that pump. Now, let me see if I can't pull this up. And we'll get a better visual aspect of this if I pull the right one. And it doesn't have it. That's great. Okay, so I won't be able to do that then. Give me 1 second and I'll pull another one for you. So we see this. So you're probably wondering what this is. Remember I was telling you we're going to change the field from the top and the bottom? How one's bigger and one's smaller? Well, you put magnets on the bottom, you're going to get a bigger field if you do the gravity flyer. So what is this? It's one field pushing against the other in compression. Here's the point where it releases the energy the right way. You know, you always see it. Center comes up like this. It's like an onion. You could start to see it right here. It's creating the onion effect. All the field lines want to go up, but they have to stay outside the dielectric. That's the point where it pulls up. That's what you need to know. So, anyway, there's that one. And there's a couple more I'd like to show, but they didn't pull in the video. And what it actually shows is when you create geometry and you go around in circles, the line starts to swirl up here like this. And that's what it does. And then there was another one that showed the pumping field. And I'll have to go back and pull it again. Because when you start to see them all work together, you'll start to understand it. The thing is people only get it like partial a bit right once in a while. They're not pulling the whole thing. They're not getting it all out there. So just so you know that's kind of what's going on. And I wanted to explain that. And I started with the wire because I needed everybody to understand where we actually see all this stuff at, why we're starting to see it in there, and what's going on with it. You have to start to understand energy on its level, not on what you think it is. So anyway, that's kind of my understanding of it. Thank you, Crypto, for coming in and putting up all the comments and stuff. I'm going to go ahead and invite Mike. I know he was out there, so sorry, guys. Give me just a second. There you go, Mike. I sent it. So you should have it already. Gerald, anytime you want to pop in, you're welcome. Anyway, guys, I try to get this understanding out there, and I can't give away the whole ball game because I have to wait for Gerald to give his presentation before I can give you the actual geometries and what you're supposed to do with them. And I hope in Gerald's presentation he presents that for you because it's not so much every geometry you need, but the basic understanding of one geometry form and why it's doing what it's doing. I can tell you this, though. When you start to work in this stuff and somebody starts to go off proton, neutron, that's outstanding. But we're not on that level right now. We're simply understanding the fields. To understand this technology, you must understand the fields. Why one pushes the other. That it does that. Most people don't understand that. They think, oh my God, I got to put this frame around it and create this big field on the inside, right? Well, yeah, that's true if you want to create energy in that way, but you're creating I don't know, I want to say this, a forced compression in there when you do it. And that's the reason they do it. But do you need it all the time? No, you don't. So, hey, Mike, what's up? Let me put on my head.
How's it going? Yep. So, interesting night last night.
Yeah. That was strange. I got a little going. So, sorry about what happened, man.
No, it's nothing to do with you at all. It's just, certain people, they say stuff and they know the policies. And, I got flagged. And, they told me the timestamp of where it happened, and I know who was involved in it. I've already sent that person an email what happened, and until they can prove to me that they can conduct themselves properly and not get me banned, right?
Yeah.
I can't afford to. I can't afford to take the strikes. You know what I mean?
I'm right there with you. I got the same warning on my channel, and that's why I said absolutely no to talking anything about that subject. Okay, we're just not going to do it.
Yeah,
I didn't get to watch last night. I jumped in like on the comment section, jumped out, so I really don't know what's going on, but I know what subject he's talking about. And we've talked about actually doing a separate Patreon or something about it. So I'll shut up. Sorry, Mike.
No, it's okay. It's just, everybody knows what the policies are. And that person stepped over the line, and I almost got a strike for it last night. And as a result, I actually lost the show. They took it off. But the problem was I wasn't able to download it before they did that. So I've actually lost that whole show. So I can't really do anything about it. I'm kind of stuck that way. So
I think Ben might have
sucks.
maybe Ben might have it.
Yeah, I think he does. Because he does it on a separate recording, so he may be able to get it for you. Yeah, Ben says he got it downloaded.
But on the happy note, I want to show you guys something really fast here. Just bear with me.
Okay, cool. What do you got?
I'll show you. Just going to change my camera view here.
New laptop.
Oh, brand new. Lenovo. Brand new.
Huh. Nice.
Very nice.
Touch screen. Hold on a sec. Touch screen and everything.
Oh, now you won't be like getting kicked off of it all the time, huh?
Yeah. It's got 0.5 terabyte memory, 8 gig of RAM, i5 core. So it's got a fast core in it. Now I got my Fusion. I can just show you.
Nice.
That's cool. Oh, Fusion 360. I love that program. I'm on that thing a lot.
Yeah. So I design all my stuff in Fusion. And look how fast it is. Like, look how fast it boots up now.
Nice.
Night and day.
Yeah.
Now
I'm used to that.
Yeah, you shouldn't have a problem for crashing on live now.
Yeah.
Awesome.
So, pretty happy with that. So it's actually this one's actually touchscreen as well. It was listed for $749. It was on sale for $649. And then there was another model I wanted to buy at Best Buy. So I go, okay, I'll get this that model there. And she goes, well, I don't have it in stock. And I'm thinking about it for a second and going, okay, if you don't have it in stock, why is it on display?
Yeah,
Right?
I hate
You know,
that.
if it's on display, where is it? You guys should have it in stock. So, anyways, I made a bit of a stink about it. You know, I was nice about it, but you know, I think she got my point. So she led me over to this one. So I saw it. Actually, had a better core. The other one, I think, I can't remember what core, but it was slower than the i5, and um, she gave it to me for $599. But the
Nice.
list price of the other one, so she matched the price. So I got it. Yeah. Yeah, so I'm just breaking her in, doing the updates on it. Yeah, it's great. I like it. The screen is beautiful on it. Really good resolution.
Nice.
It's got Adobe Sound. Yeah, Adobe Audio. It's got 2 speakers, one on either side. Touch screen. Yeah, it's got all the bells and whistles. Actually, it's even got a fingerprint scan too there on the side.
Oh, that's cool.
Yeah.
Well, now you're
So,
set,
yeah.
Mike.
Yep. No excuses now, right?
Yeah, no excuses at all, man. Got it rolling.
So I'm just getting this thing all set up to do what I gotta do. I gotta build some cells today. That's on my agenda. So yeah, busy all the time.
Very good.
So yeah, I just thought I'd hop on and yeah, I just want to clear that. You know, I'm not pissed at anybody for what happened last night. You know, it's just the person had to choose his words a little bit more wisely and think. You know, I'm on somebody else's platform. If I say something wrong like what he did, and now I'm taking strikes for it, you know, I'm going to lose my channel. That's the last thing I want to happen, right?
Yeah.
Yep.
So
It's hard
But-
sometimes to curb your mouth and realize that you're on somebody else's channel, but I know that like Nathan put me on his live thing, so I do the best I can to shut my mouth. It's but sometimes difficult because this tech and the stuff we're doing leads to certain things. But we gotta shut those certain things off quick before we express.
you got to know ahead of time, and you just kind of have to choose your words wisely and know
Yeah.
what you should say and when to hold back, and you know, to keep yourself safe. But it's more accountability when you're going on somebody else's stream. You know, you got to have manners, and to a point, right? You know,
Yeah.
we're all human beings. You know, all of us can get pissed off at each other for what they say to you. We're human, right?
Mhm.
Sometimes we will take offense to something that somebody says. We're human. It happens. But, you know, we're adults and we got to conduct ourselves as adults, right? You know, if we go on here and it's friggin' Roadhouse every Friday night, you know what I mean? Like totally chairs
Man,
and
I talk-
tables, you know?
I was so used to talking like a sailor, but after doing so many lives and you're working on it, I don't talk like that anymore.
But you know what? Okay. They're words, but what makes them bad is the context in which they're used,
Of course,
right?
Yeah.
A word is a word, but the way you use it makes that word offensive or not offensive.
Yeah, and I'm sorry about that, Mike. I kind of blew up yesterday.
No. I understand. It's not like it's the first time, you know, right?
Yeah, but I should know better.
Well, here's the word I wanted to go to Antarctica and look for a fuck. You guys are thinking all perverted or bad, right? But I'm saying it wrong. It's really a seal in French.
it's the context.
Yeah,
It's a
exactly,
context.
right? So I'm playing, but it's really a seal in French. I think it's pronounced a little bit differently, though.
Yeah, I just avoid the subject altogether, Mike. It's what I do to stop it, because it's not the first word that's said; it's where it leads to, and then you get hit.
and it's too easy to lead to where you get hit.
Yeah.
Yeah.
So
So yeah, it's you got to have your own built-in filter, right?
yeah. So with all that out of the way, if you guys don't mind,
No problem.
let's get on to some technology.
I missed your opening. Okay. I caught right at the part where you're putting your whiteboard away, and you were talking about how the field is produced around the wire. And I've discussed this before. It's not in the wire, it's around the wire. Or as you would say, in and around the wire, because it spirals around the wire as it's going through the other way in the center of the coil. At least that's
Dollar
I don't know if you see it the same way.
Because I don't have your coil, I can't see it your way until I do. If that makes any sense.
Totally.
Yeah.
Totally. I get that. What were you saying, Mike, before I cut you off there?
Like Steinmetz has a very good diagram, and actually Dollard uses it in his energy synthesis lecture, and it shows exactly the two power lines cut in half, all right, a cross section, and it shows the lines of force going around it. And he does a really, really good analogy of what's going on around the wire in between the two wires.
But it's slightly deceiving because those lines of force, although they are lines of force and the force degrades in distance, it's still spiraling around. It's not like a solid column, right?
Yeah.
So it's a little deceiving the way he describes it, but he's right. He is right.
I think what he was getting to, when you get enough power going between the wires, you get a point of saturation. He says, you can only put so much water in a bottle, right? And when that space gets so overly saturated, that's when you get the blast. And that's what happens, right? Because it just cannot feed any more potential energy in that space, right?
So,
which makes total sense.
But when you change the point of saturation left or right, okay, you start changing the direction of flow of energy. So if you're equal distance and then your saturation point's in the center, when you move a little bit this way, this field is always trying to pull this way while this field is getting oversaturated, right? So your directional flow will go in one direction. And
you get a distortion.
That's how you get force in one direction.
I was going to say, wouldn't you induce current into that second line, though, because it's closer?
You have to watch the point in the center because you get the spark in between if you go too far, or you'll start to get plasma. But if you have this amount to move and you move quarter of the way, okay, you're still getting it. Now, how close can I get before I get to that plasma state?
That's true. Right. Yeah.
Or the blast. Yeah.
Yep. Yeah, I know what you mean. I think they're using that purposefully to gather energy because of the way that the lines, your high voltage lines are set up.
I think cryptically, that's exactly what's going on.
Yeah, well, you could use them as an antenna. That's something I still have to show on video. But the other part of that is when it's long distance, they have three lines they're not close together, but you got one going one way, one going the other way, and then you got one in the middle. And I always wondered, what is that one in the middle? Well, after doing a ton of tests and learning what I've been learning, I don't know. It's just a thought, right? Is it possible? Yeah. Is it probable? It's kind of 60-40 that it isn't probable, but it's definitely possible because of the high voltage and how it works.
A lot like the ones near my place, they transport 44,000 volts going through the high voltage lines. If you get a coil or even an antenna, I've seen this guy. He lives on a farm. I don't know what state he's in, but I follow him. I'll have to look him up. He just got a bare copper wire. It's about 500 feet long. Put it on two wooden stakes in the ground, and he's got a high voltage transmission line above him that's putting out about 44,000 volts, give or take. and he has, the big oil-filled capacitors, the ones that I have. So he puts that on the ground, hooks up the one wire to it, the other one to ground, and hooks it up. And within a matter of seconds, he's got well over 2 kilovolts in that capacitor. Just from the potential ambient space being near it, he's getting huge amount of power going through it, and very, very fast. Right?
Yeah. I can't remember who did the experiment. It might have been T. Henry Morey. It might have been somebody else. But that exact experiment that you're talking about, the line came down into a wood box. Then from the wood box, they're running their house. And everybody's like, oh, the magic box. But I'm 98% sure I knew exactly what was in that box. And it has to do with, go ahead.
He said he had a special crystal. He called it a Swiss emerald crystal something. You could only find it in Switzerland. I don't know how that related to this circuit, but yeah, I know what you're getting at.
Yeah, well, I don't know about the whole crystal thing. You could definitely do with a series of capacitors running it through the center of an open core coil like mine, kind of like a current measure coil, but slightly different. You add the way you build it has to have more capacitive link to the wire. Go ahead.
I think this is just a hunch. I think what he had was a special type quartz crystal, and he had the little wire attached on it like the cat's whisker, they call it. That's when they were doing the first test at Bell Labs, making the transistor, their frequency transistor. And I think that's what he was working on. Maybe he might have been kind of ahead everybody in the development.
Les Brown. You just made Les Brown pop into my head. Okay, so listen, that crystal with the cat's whisker, what you're talking about, right? That's like the first radio sort of thing, right? Mm-hmm. Well, Les Brown tells a story how he built like a 30 some odd foot, I think it's 36 foot, wooden pyramid. And I've talked about the story before. And when he attached the inner apex of the pyramid to the ground through cable, the way he attached it was sheep's wool, right? Mm-hmm. What if that's like the basic principle is radio?
Yeah.
Do you know what I mean by that? Like the ground being the crystal, so to speak, and then that sheep's wool that he used would be like the cat's whisker, and the pyramid would be like an antenna.
It'd be the wool that he used actually was a very good dielectric.
Yeah.
So any charge that was on that wire was creating, basically the heavy side component going through that sheep's wool, and then, eventually going to ground through the pancake coil that he had on the ground that was stapled to the ground on a plywood, and he had the end of the. Yes, exactly. Wardenclyffe, same thing. It's the same setup as Wardenclyffe.
Yeah.
Same setup as most Tesla coils. He just did it with actually not even using any power input. He was just tapping into the sky by the wooden pyramid.
Well, they also tapped into the ground through the water.
Yeah, sure. It's completing the connection.
It was an oscillation pump in the center. Mm-hmm. That's really what it was.
Well, the Earth's a giant asymmetrical capacitor, right? So basically what Tesla did was learn how to tap it.
Yeah. That's it.
Yeah. That's kind of what we're doing, right?
That's exactly what we're doing.
Yeah.
Completing the circuit.
Sorry, we're just doing it in a coil form where it changes what's the earth and what's the ether at the locality of it. Like Joe likes to say, it's where we're doing it at is different. But it is still inside the earth. We could tap this in space, no problem. You know what I mean? Because we don't need necessarily the earth to create it. We're working within the confines of the earth, so we have to take it into account.
Well, if the earth is like sorry, Mike, go ahead.
No, go ahead.
If the earth is a giant capacitor and the dielectric has forcing between the two plates when it's pulsed, basically, once we have the mechanism, it's from here to the upper atmosphere like that, because think of how fast the dielectric travels between the two plates, right?
Yeah, you're creating that differential. I think that's a key thing, is a differential between plate A and plate B. If you have one that has a high area of concentration to a low concentration, that area of high concentration wants to go to the low concentration, which is your earth ground. And that's where it happens right there. It's the differential between A and B.
Providing you have the right parameters or things connected in the right way. You have to take heat and cold into consideration and
Humidity. Yeah, it's like the atmosphere. When you get a thunderstorm, it gets the proper conditions of conductivity in the atmosphere. And when those conditions of humidity, dryness, whatever, wind, everything. When you get that recipe just right, you get lightning.
well, I'm gonna show this on video soon. Now that I got these, oh, you guys are gonna laugh at me. I hope you're ready for this. You guys ready to laugh at me?
Yeah.
Rookie move. Remember last week I said I blew a whole bunch of transistors? I'll bow my head in shame. It was a wire.
It was the wire.
It was a freaking wire, man. You know the leads that come off your function generator? One of my leads was blown. And I test it all the time, but it was just enough to make the connection for the tester to pick it up. Not enough to work. I was pissed, man. Because I had taken apart boards and stuff, and I was like, yeah, I got to change these transistors. And then I found the problem, and I realized I didn't blow one damn transistor.
Wow. That's gotta suck.
It did. It did. But now I've got like all kinds of extras, and I'm doing crazy tests with them. And, you know, we'll see.
Very cool.
Yeah. That MJ E13009, dude, I'm getting ball lightning every time I turn it on. Like, I'm getting purple, pink, and white, and it's just gorgeous inside that neon. I want to get a big neon sign, you know. I want to hook it up and see what happens. See if I can get a ball happening in one of those signs going from point to point. I don't know. I think it would be interesting for sure.
Yeah.
Did you hear who was it that was talking? I think it was Jack Safardi.
Yeah, you were getting into that last night in the chat, and we didn't get to understand what was going on yet.
He was talking about how we're ball lightning. Our consciousness is held within our body, and we're ball lightning. It's in his paper.
Is that the same guy that was on oh god, on with Tim?
Scientist, Jeremy Reeves?
Yeah, there you go.
Yeah, you're absolutely right, Gerald. That was a really fascinating part.
He
The
was
guy
bitching about the free energy community and Ashton Forbes and Sal
told me-
Baez and
Didn't he tell everybody they're full of, you know what?
Oh, yeah.
Whole
Yeah.
shitstorm of drama on Twitter X now over it, apparently.
Yeah, but he told us we're schmucks too.
yeah, but you know what? I don't listen to Jack. Jack's an 85-year-old freaking narcissist, man. He's the kind of guy you look at and you laugh.
70-year
He's the kind of guy at the-
CIA operative, right?
He's the kind of guy at the party while we're all having beers. Hey, we're all having beers and he's sitting in the corner telling us stories about things he did. And we're like, right on, Jack. Okay, Jack, pass me the beer.
Yeah.
He's cool.
Dude,
But he's
we
a dick.
better be smoking something if I have to listen to him for more than 10 minutes after he just puts everybody down.
But you know what, though? Here is the thing.
I was microdosing mushrooms that day. Not today, but that day I was hilariously, and you also just happened to publish that Star Trek mushroom video. It was quite a synchronicity.
Hey, Jack's a drinking game. You take a drink every time he says schmuck. You'd be drunk by
Oh.
the time he's done the video.
Oh, one of us
10
would be
minutes, man.
standing there
Right?
sitting-
Oh,
Yeah, I don't know. I don't know. That guy just kind of doesn't rub me the right way. You know.
Yeah, it didn't rub me the right way, that's for sure. Definitely the
what?
wrong way.
I don't
It's sandpaper.
Yeah, I don't trust Jack in the sense that like if we were building something,
Given the chance, Jack will rub your
Right?
grandma in the right way. Don't you worry
But-
about that.
but he's a fucking funny guy, man. I'm telling you.
You'll rub your
Makes
grandma
me
the
laugh.
right way.
Well, that's Jack for you, right? He's
But-
a legend.
Yeah,
He
but the
rubs
problem is
everybody the wrong way.
he likes stirring the pot. It's like, concentrate on your own stuff. It's easy to criticize or not like what somebody else is doing, but it seems like he's doing it for attention sometimes. I don't know.
I
That's
think-
what I get from it.
I think you're right, but you know what? Ashton Forbes said this, and I agree with him. He's showing his true colors in the sense where he's kind of showing his fear. I mean, think about it. He came out against all of us, came out against Ashton Forbes, Sal Paez, all the guys that are talking about ball lightning and anti-gravity and the way that it works so that everybody can understand. Not some asshole, the fucking PhD, pardon my language. Sorry. But those academics that rely on their papers and their prowess of the bullshit that comes out of their mouths, okay, when it comes down to how they describe stuff, it's a joke. But
Well, you know what?
ultimately,
I just-
talk
Like
you and
how
I.
they denounce it while simultaneously are working on it.
What's that,
Well,
Bernie?
Oh, I'm gonna debunk this, even though all my projects are actually that.
You got so much interference going on, I can't hear it.
That's it.
I can't get it. All I can say about that guy is attack the science, not the person, and he keeps attacking the people. And I think that's wrong.
Yeah.
It's okay to attack
No.
the science.
But
You know
think
what?
about
There
that for a
isn't-
second, though. That shows us that we're right. Attack me all you want. If you're not attacking the science I'm talking about, it means I'm right. So go ahead, bitch away, please. I'll even listen. You know what I mean by that?
You know what? It seems like all the old school guys like that like to fight and squabble over BS.
Yeah.
You know,
He's from the
concentrate
Bronx,
on your.
man.
Yeah, but you know what? That's still not an excuse. Guys that are true into science are guys that concentrate on their stuff, not trying to discredit or slander other guys that are working on similar stuff, but in a different direction.
Okay, well, and I totally get that, but Jack was part of the MK Ultra programming systems. So
Well, think about it.
everything
Think about
he
it.
does
That's a
is
lot.
manipulative. Everything.
Yeah.
Don't think he
Yes.
came on there to bitch just because he was mad. He went on there to bitch because he was trying to put a point out. And what's that point? They're scared. Dude, they know it's
Yeah.
coming. They can't stop
Yeah.
it.
They can't stop.
All they
You
can do
can't-
is disappear people. And they're not going to do that in mass.
Well, you know what the problem is with this stuff? We have a lot of the components everywhere. They're scattered. It's bringing them into focus and where they fit. People aren't understanding that yet. Once you get that relationship down, this stuff is easy. It starts to flow. They don't
Yeah,
want
all
you
the-
to see the directions of relationship in everything.
That way.
Yeah, all the pieces of the puzzle are there. You just have to sort it out, put it together right.
But the thing is they've been moving the pieces of the puzzle for the last 50 years by changing the word. You change the meaning of the word. You
Yeah,
change the
yeah.
action that the people do around that word. And that's why
That's all
we've been-
part of, and that's all
Hey.
part of MK Ultra.
Yeah.
That must be pissing them off to great ends that I don't describe it in their words, because now you have no shield to hide behind. I'm taking
Exactly.
that away by giving you the basic understanding of things.
I've been saying it for years. Academic bullshit. What is it? It's just a bunch of word fluff for all the same shit we're working on. We're just talking about it in the terms of backyard mechanics,
Yeah.
right?
Yeah.
That's it.
Understandable terminology.
There you go.
Exactly. I get tongue-tied when I tried to talk in the terms of academia because
Yeah.
it just
And-
seems
and
too
it-
much like a circle jerk. You know, like it's just. Sorry, maybe I shouldn't use that term. It just seems too much like having a shower with a raincoat on. It's bull, you know. I don't know. Maybe it's just me.
Oh my God. You know that's showing up on the Star Trek episode, right? You know it's coming,
Yeah.
Gerald.
Sure.
I let you
Yes.
finish. I wanted to hear it. Oh,
All right, you got it.
oh, that's
Beam
hilarious.
me up, Mikey Scuddy.
Uh, episode
Oh.
3 coming.
Oh, oh my God. That's so
Yeah.
bad. Every time somebody does that, I go, oh, you stepped in it now.
Yeah, you're getting it now.
Yeah.
Front
Yeah.
and center. No.
You're getting the video. What do you call recognition?
Yeah, that's it.
Oh,
the captain
man.
spoke.
Beautiful.
I love it.
That's so
Yeah.
funny, dude. Oh,
Yeah, I harp on academia. It sucks that there's so
I-
many smart people out there that sacrifice so much of their time for that kind of crap and got nowhere.
well, that's why I like Victor so much, because he comes in and he's flowing with us and understanding the idea and concepts of everything and puts the math right to it where we're at. Not,
Yeah.
hey, this is above you. It's right here. This is where you are. And I,
Yeah.
I just think that's beautiful.
Yeah, I like Victor. I was looking at the paper that he was talking about. I'm about 80% through it. I agree with a good part of it, not all of it. Just like I was looking into Fractal Woman. She's very intelligent. I agree with some of what she says, not all of it. Just
Well,
like everyone else, right?
you do realize, Gerald, that not everybody sees the experiments you have, right? So
That's
they're
true.
making a connection that doesn't actually exist. And then until they can understand where you're at and why it's doing what it's doing, they can't make the right one. You know what I mean?
Yeah.
Oh,
Yeah.
once you present what you're doing, then everything will start to fall in line. You get what I'm
Speaking
saying?
of which, I gotta say this. I gotta present real soon, dude, because just your work and you know Sean coming on and then Ian and everybody, like I'm not even gonna have to present. You guys are explaining it just by us. Just it's unfolding, right? So, but I'm going to do it ASAP. I need that editing program. That's the only thing I need to finish.
Oh,
The paper
okay.
is written.
I'll
Yeah.
send it to you.
Awesome. Because then I could do my little edits and put together what I need to finish.
If you need some help when you get on it to figure it out, let me know and I'll walk you through it.
Awesome.
Did you get your Facebook?
No, I didn't have time to do it yesterday. I had to finish doing some winter prep in my yard because it's
I get
coming
it.
quick here. Like Mike, we get a lot of snow. So,
I have fake grass. I'm in California.
oh,
So-
you're lucky in that sense.
I have to do nothing.
Yeah. I get 4 feet of snow every year at least.
Oh,
We're getting less and less every year. Last
Yeah,
year,
that's
we
actually
got-
been that was the trend for a while, but last year we got what we used to get. We got a good 4 feet.
we got barely anything last year.
Really, eh? Different parts, I guess.
Yeah, we were getting less snow than Michigan, and Michigan's further south than us.
That changes everything. It like Nathan, you don't get snow, so your hydro flow around your area depends on rain and certain times of the year, right? We get snow, and our farmers depend on that. So when we don't get snow, well,
I think we got snow like 5 years ago. Like
oh yeah,
we don't get
5
snow.
years.
Yeah,
No.
5 years ago we got to take 1 or 2 days to get on a little shield thing and slide down it, and then that was it. And then it went away. We never saw it
Nice.
again for forever.
that's cool.
I don't mind the snow. I think for me, it's the cold that really bothers me.
Oh, it hurts your bones. Oh, my back
Yeah.
hurts.
Because
The plates in
Anything
my back
below
hurt.
minus 10, anything below minus 10, yeah, it's uncomfortable at that point.
I just picked up 2 old snowmobiles to go teach my kids how to snowmobile. So this year I'm hoping for snow. You know what a snowmobile is, right, Nathan?
Yeah.
Okay. I had to ask because you're in
Hey,
California.
We ran those things in the dirt, man. That big tread on the back.
Yeah.
It was like a motorcycle tire for us, man. It was like it's forcing it everywhere.
I've watched them literally like zip across the lake. It's kind of a sport, right? Man,
Yeah,
that's
it's
a blast. Yeah. You've seen that too,
Hydroplane
Mike?
right across. Yeah.
Jeremiah's on.
Jeremiah, we'll just grab a coffee. I'll be right back.
More balls.
Always. But this one looks like it's stationary. It's actually spinning really quickly. I'll go ahead and shut off the power supply.
Oh, I see it now. Okay.
Yeah, so what we have here is a little dipole washer on the back to close the field lines, and 2 magnets on the front, north and south. I have a quadrupole setup as well, and a new chassis that Simon C designed, based on what I asked him to do. And here we have a full enclosure, so I want to turn this into a easily, transferable kind of product. But these 2 little magnets, so what happens is when we spin up the motor, this will create a rotating magnetic field. And because of the strength of neodymium magnets being rather incredible, scientifically speaking, compared to the amount of electromagnetic energy we need to put in, we can take something like this aluminum ball and just set it on top of there with those magnets rotating, and we can see that it immediately starts to pick up some speed. And we can get it going rather fast. So
that'd be drag, right?
That's like my magnetic stir, where you just put the cup on there, put the magnet inside, spins, and stirs
Yeah, but
up
that's
my,
aluminum.
mixture.
Right, exactly. So let me grab the quadrupole.
Well, because of the magnetic field, now will that ball heat up because you're creating eddy currents on it? Would it heat
No,
up a little bit?
it's surprisingly efficient. Actually, haven't had any heat so far. I mean, even if I do something simple like, take this aluminum foil
Right.
and just set it on top, you'll see the magnetic fields grab it, and
How about copper? Do you have a piece of thin copper? That would probably create some heat.
Oh yeah,
Because
you
you'll
can
have
definitely
more.
get it. But you have a quadrupole setup and a dipole setup. So one of the things that I was looking for is what is the difference in terms of the coupling coefficient between a dipole and a quadrupole. This one technically has, twice the magnets, so twice the total flux. But the field lines are closed a lot closer, so we end up with a different field gradient in terms of the total field size. So like these poles on this dipole will extend a lot farther out than these poles on the quadrupole, which will be pretty tightly matched against the opposing pairs. So north-south, north-south, compared to just north-south. But it's a fun little thing, and it's powered by one of these little DVD-ROM motors, which are plentiful and everywhere. These are the motors that extend and retract the tray for your CD or DVD player inside of a desktop.
Oh, right.
So they're all over the place, and they work perfectly well. And these are standard washers from Home Depot, so it's pretty easy to 3D print all this stuff out and make yourself a nice little dipole trap. Now, what's interesting is, this dipole trap allows us to see on a macroscopic scale how particle traps work, like dipole and quadrupole traps that operate on a microscopic or particle scale. And so by studying the field dynamics and geometry, we gain a better understanding. So if I introduce electrostatics here, and now I have orthogonal fields to the rotating B flux of these individual magnets, then we might be able to observe some field boundary conditions and potentially gravitational effects, which is why I built a couple of these little things. And I've also got a couple of gyros that are somewhat fun too. I think I showed those off last time. But I figured I'd jump on real quick and have a conversation with y'all because it sounded pretty interesting.
That's cool.
Yeah, looks cool. I like that.
I could have fun with that.
And it doesn't take much to make it either.
No, exactly. It's super, super easy, and it's a nice little toy for up and coming engineers or self-taught engineers to play around with to gain a physical understanding of field dynamics. And it's infinitely more useful than crunching numbers and mathematically computing ideal situations, because this you get to put your hands on and play around with it, and it's instantaneous gratification. You just stick anything on there, ferromagnetic or non-ferromagnetic, and it'll spin it, which is just fantastic. So you could even spin carbon. Technically, it just doesn't couple quite as well because carbon is resistive, but even a resistive material like carbon, you can spin that. So it's a nice way to study the dynamics of different materials based on their electron drift velocity and their total eddy current coupling coefficient.
And make no mistake, you could spin your balls too.
100%.
I had to say that too.
Spinning
Got
balls.
this thing with gray hairy balls. It has to do with Mike and his shirt.
Yeah.
I still need to get one of those old bald T-shirt.
Me
Yeah, but
too.
you gotta be careful. You gotta be careful, G. You don't want to get your balls twisted in a knot.
Oh, especially when you're spinning them.
Oh,
That's awesome.
oh,
No, it's a little.
Yeah,
something.
I actually want to build that. That's kind of neat. I need a 3D printer though. That's next.
Yeah,
I
the
have
cool
to-
part is they're super cheap to make. I don't know exactly what the cost is. I suppose it'd probably be something roughly about like $6. But you know, yeah, cheap.
Yeah.
nice.
Yeah, just
Yeah,
looking
that'd
at
be
the
interesting.
comments.
Yeah, you know, you can throw a bismuth ball on there too. Bismuth is obviously extremely diamagnetic, and it'll spin that.
Well, I'd like to see the bismuth if you had it. That'd be cool.
You want me to grab a chunk of bismuth and toss it on there?
Yeah.
Will it spin?
Or if you,
Oh, yeah.
or if you have like a,
It
or
spins
even like a
anything
plastic.
that's conductive enough for the eddy currents to transfer through. So
Now, if you were to get, like, say, like a glass, like a small glass, and put bismuth in there in the liquid state, and see if it will actually start spinning it in the liquid state.
a small glass, what?
Yeah, like a small drinking glass. Put the bismuth
underneath
inside
it,
in the
you mean?
liquid state, and then put the magnet spinner underneath it, and see if you can get the liquid bismuth to spin up.
Yeah,
Don't
but
they usually have a magnet inside the glass of water though?
You could probably do that too.
Because that'd create a vortex for sure. I don't know that spinning it under it would do it. It might. I don't know. I don't think it would. But
Depends on the strength of the vortex, I guess.
yeah.
too much friction on my bismuth puck. I was trying to spin it, but it's a more
Heavy.
flat disc, so there's just I have a little point on it, but it's just too high of a friction for it to grab hold. I would have to actually cast a bismuth sphere in order to show this. So my apologies.
Right on.
It is what it is.
Yeah.
Get a bismuth vortex going, that'd be kind of neat. And then
Yeah.
hit it with electrostatic charge.
Does anybody here remember the resonant frequency of quartz? Is it 19,600 hertz?
746 kilohertz according to one report, and 746 terahertz according to another report.
Really?
I don't think either of those numbers are necessarily accurate, and I think both of them came from the same source, which was misinterpreted, and I have no idea what that source is, but they are in the lore of the UFO community. And as far as traceability, I've never found the original article or the source for where that number came from. But they're not like peer-reviewed papers or anything on those lines. They're just simply, quotes of numbers that claim the natural resonance atomically of the quartz, which is different than its resonant frequency. Say, okay, so we need to clarify something here, and this has been one of those things that I've had to explain on multiple occasions when talking about the potential atomic frequency of quartz. So you have several different ways to approach an atomic frequency. You have the EPR frequency, the DNO frequency. You have the thickness frequency, which is your polariton condensate frequency. the normal way that a quartz crystal oscillates in, say, a radio or something like that, you're talking down into the double-digit kilohertz. So, like, you can have a 3 kilohertz oscillator or a 24.5 kilohertz oscillator crystal, right? But that's in the longitudinal mode. In terms of thickening and thinning, that's the piezoelectric response, not the actual atomic frequency. So
I think that's the
frequency,
frequency that I was told, though, is the one you just mentioned. Go ahead, continue. Sorry.
my main point was that about that. I hope that didn't disrupt the mic. Oh, it's still on.
Nope, you're still on. Go ahead.
Okay, cool. Yeah, so my main point was there are a variety of different resonances that you can achieve within a quartz crystal, and these resonance modes have a variety of different applications. But in terms of what is the true resonance of pure, atomic quartz in a perfect crystalline lattice at the lattice structure level, at that fine scale, which should be something that's independent of the total size or cut or shape of the crystal, right? This should be like a natural resonant frequency that it doesn't matter what kind of way this quartz was made, as long as it's a pure quartz crystal, it should have this natural atomic frequency. That's what we're looking for, is something that doesn't change.
I know what you're talking about. That's hard to do, though, because every crystal is different when it comes to their diameter.
The thing is, there is a natural atomic frequency that is the same in every single crystal, and that's what we're actually trying to find. One that is unanimous with the natural isotopic level of carbon on planet Earth, of silicon on planet Earth, the various other elements that might form impurities in the crystal. So we have, there's this fairly stable Terran ratio mixture of isotopes and non-isotopes in the elements that compose natural quartz. And just kind of, taking the average, if we remove the impurities, we end up with just a very pure crystalline structure, like, say, for example, synthetic quartz. The way that almost all quartz in all devices that you currently use today is not plucked out of the earth like it used to be. It's not mined. It is grown inside of giant vats containing the right catalyst materials started from a seed crystal. And it's a rather beautiful process and absolutely incredible to see the end result. But the synthetic quartz is basically free of impurities, and so naturally and atomically it has a consistent atomic frequency, which is well above the frequency that it could possibly ever be used for in radio applications. The atomic frequency is so high that it should technically be in the terahertz, because that's where we see most molecular Brownian motion interactions taking place.
So terahertz is after gigahertz, correct?
Right.
Okay.
Terahertz is the next step past gigahertz.
Okay. I just wanted to clarify that.
No, good thing to clarify, right? Because past terahertz, then we get, into petahertz, and past that we get into tetrahertz, and ridiculous numbers that we as humans have no business even trying to consider, because there's absolutely no way to access them right now at our technological standpoint.
Well, even if we did, what are you going to do with them? Like, once you've reached anti-gravity and the other aspects of this tech, you don't need to go deeper.
Right. Well, no need to go deeper. I mean, once you reach anti-gravity and the ends of this tech, the only way to go is deeper. And the end result is, if we can do it, we must do it. And that's a policy of science that is very much opposed. I mean, every single time somebody opens up a new particle collider or even speculates about the possibility of one, besides the fact that my personal opinion on those is that they're a waste of money, because we can do low energy, high concentration collisions and get the same result with LENR. But there's always this big media hype about, is it going to create a black hole and devour the Earth? And other stupid
way of getting more like funding.
That. Yeah, for money. It's a black hole for money.
Yeah. Black hole
it certainly is.
Way to get more funding. Start complaining about it. Get it into the public eye. Oh, we just achieved a new particle. We call it a boson. Like, come on, give me a break, man. It's all a bunch of bullshit written by a bunch of guys trying to justify their careers.
It's a
You know-
Bose-Einstein. Yeah, it's a Bose-Einstein condensate.
Yeah, they say that. What's a Bose-Einstein condensate?
I didn't say Bose. I said Bose-Einstein condensate.
Oh, I like that one. That's good.
Sorry, I understand. I watched the releases when they first came out, and big pat on the back to everybody that was involved, right? But I looked at it as a field interaction, and they looked at it as a particle interaction, and so our differences and opinions.
I look
It's
at
nobody, so it doesn't really matter. But when I applied the fundamental forces to the speculative proposition that they had at a 5 sigma level of uncertainty, I spotted a problem, and so I'm not going to get into it because it's going to lose everybody, and
Well, hey,
I'm
you
not
know I'm
qualified
gonna
anyway.
say it.
So
You know I'm going to say it, Nathan. You know it. CERN is a 50-year circle jerk. Okay? I'm sorry, but it just is. What did they come up with? What, God particle? Really? Show me it.
yeah, the Higgs boson.
Oh.
Is the
The
Higgs
Higgs
boson a
boson.
field effect, or
Been
is it actually a
chasing
particle?
That thing like the comment sections. I
And
don't
that's
know.
what this is fundamentally what I was pushing at. Is the Higgs boson a field effect or a particle? Is that simply a number that we predicted to expect because it's a fundamental energy level between various field forces, or is it actually a physical particle that exists? And the difference between those two may seem rather trivial, but it's significant.
Well, you know what?
It's either
all
an emergent effect or it's a fundamental, kind of particle. So which one
But
is
like Nathan puts it, though, in the grand scheme, at the end of the day, who cares? Like, I mean, no offense to you. I'm not saying that to be insulting. It's not what I mean.
No, I'm not insulting at all.
when
And
it
I
comes to,
completely
like,
agree.
CERN,
It doesn't really freaking matter because
Yeah,
if we can't use it, then it
Does
means
it make
nothing.
my coffee boil quicker? Can I get to work faster? Can I fly to work rather than drive? No? Then what the are we spending our money on? You know what I mean? I know I bust the balls of academia. This is why the system's
Well, hey,
broken.
okay. So
It's
this is
all
why
about
it's
those guys
important.
at the top collecting for their pockets. You know what I mean?
If the Higgs boson is the information carrier for the Higgs field, and the Higgs field actually exists, and that is what gives things physical mass, then by understanding it and manipulating it, yes, we could negate mass. So that's why it would be important for, can you fly to work rather than have to drive there? If it was accurate and if it is true. Now that's the real question, isn't it? Because if it's
Give me
if it's
$50
released,
billion, I'll have us in the air in 6 months, man. Like they've had
Exactly.
50 years.
Yeah.
Yeah.
And I understand that there's this academic idea that you must understand completely all the principles in play and all the theoretical concepts before you can possibly start to engineer. Well, that's backwards from the way it used to be. You see, the only reason why we have academia today, which has things like tenure and people who can spend an entire career as theorists and do absolutely nothing else, never having to touch a physical piece of hardware in their entire lifetime, is because it started out in the opposite direction. See, the experimentalists, the engineers, the builders created an industry where there was so much backing behind the Industrial Revolution, so much force and momentum, that it created opportunities for specialization, which allowed things like, academic theorists to now find a career which would have never been a possibility before, because they would have had to work harder and actually produce some kind of product or work on a line and create something, right, that had an economic value. But now there's this new opportunity to do just purely theoretical work. The problem is that the theoretical work has become disconnected from the physical engineering. And so now you get theoretical numbers that are pumped out constantly from the academic community, which have no relation to reality.
It's like that one guy
That's a problem.
on APEC, the fireside chat guy, where he put me to sleep for 2 hours.
Yeah.
That guy, totally disconnected from reality.
Yeah. What reality?
I need to get a suit, you know what I mean, and a fancy tie, and put a little fireplace next to me and start talking, and then I can bore people to death. Let's see how that goes over. I'll just say a bunch of smart words.
Are you talking about the guy that I walked off APEC for?
That's for it. That guy. That, oh my God, the Snorfest that was going on that day.
Yeah, people bitched about that guy.
Oh, and they didn't pull him. Like, where were the old time people with their log and they come out and throw him on top of it and run out of the building with
or
him?
the big hook. Remember the hook?
Yeah.
Come out, pull the guy out.
Yeah,
That's what we needed that time.
that was so bad, man. I mean, a fart would have got the whole room laughing, but this guy, man, you couldn't even smell it when they fucking put it to sleep. It was
That's okay.
bad.
I've learned so much about temperature gradients and what to do with it now compared to where I was then. I don't give a shit about APEC. I hate to say that. I mean, all due respect to everybody who put it together and how great it's become, but it ain't going to do nothing good for me. So
But it's missing the experiment side to it. They're getting a lot of mathematicians on there, and they're
getting
not
a lot of
blending in
theorists.
the
Yeah.
experiments.
So in,
Yeah, a lot of
the,
theorists.
in the early days of APEC, you know, when we first started it, it was an alternative to Estes Park. So that's basically the, you know, initiation of APEC, is that there's this academic community which was very exclusive and guaranteed that they had, you know, high quality, qualified participants that were going to present their stuff. The issue really came down to the fact that all these participants had a specific goal in mind. They were trying to get government funded or funded for projects and various things. So basically everybody's presentation is some form of sales.
Fundraiser.
Right, exactly. And
there you go.
and the addition of it being a fundraiser on top of it being extremely exclusive,
Not
and
just fundraiser, just bought and owned, to the point that it's like, if your results don't come back as like what your owners want, you rerun tests or simulations over and over again.
Or you don't get to present.
more so basically we were told don't come back. And so we looked at the email list and, you know, said we're going to start our own thing, right? That's going to be inclusive instead of exclusive. And that was APEC. And for years we ran it, and it was incredibly successful. We got more. There's been more people that have had an opportunity to speak about their anti-gravitational or alternative propulsion ideas on that conference than any other that has ever existed before it. The problem is we kind of ran out of people that were really pushing the boundary. And now with it getting as big as it is, because it's been mentioned so many times, and because not only this conference, but a huge
it's
group
only
effort,
gonna get bigger.
right?
There's
It's
only going to be
actually
more
becoming
people
mainstream.
coming out.
Right. So as
Oh
it
my
becomes
God.
more mainstream, people get more nervous, and you hear less of this brand new stuff. And
Oh my
unfortunately,
God.
people are seeing that this is now becoming commercially viable. So instead of talking about it, revealing their secrets, you know, just trying to get it out there, in the early days when no one was listening and it was just 60 people watching, or, you know, 150 people watching, it was no big deal. That was like, I just need to get my ideas out there into this world. But now, when it's like 4,000 people watching and you have these huge view numbers and things are actually getting out there, and there's major talk about warp drive, and you're even having fake AI videos generated about how Elon Musk has released his newest, you know, verification that they tested a warp drive in space, which is complete BS. But AI is, you know, people are generating AI videos to make claims like that. It's become so mainstream that you're even having fakers now. And the problem with that is, people are less willing to talk about their secret ideas because they're seeing money in their ideas, and when they get dollar signs in their eyes, they get real quiet.
Well, that's
Reading the
why
hard
Little
it's all
quality
about
people.
open source and just open sourcing it and making sure people don't go reclusive and don't get bought out by private interest or taken by the government.
Greeds in the hearts of men will be the downfalls of both our countries. Simple as that.
Yeah, it's that love of money, and it just keeps on coming back to haunt us as a species.
Yeah.
Well,
I don't want it.
I can tell you that's why we do shows like this, because I just don't care. I don't need their money. I just don't care. I just want to work on what I'm working on. I want to help other people work on what they're working on. Even if it's the smallest project in the world and you ask me to come on and look at your stuff, I will. Guys, that's the way it works. Okay. And I'm not above anyone else. I always look at it like they're doing something that I'm not. And That's always
Hey,
good.
whoa. I'm above my kittens. Okay?
Yeah. You got the kittens.
That's it. That's all I'm above.
The cats control Gerald's internet access.
That's so true.
They
Gotta
certainly
go
do.
on.
They knock over
That's
the
got
router.
to go on the next Star Trek, Nathan. That was perfect.
Nice.
Yeah, that was perfect. Yay, Bernie.
Oh, it's so much fun doing that, man.
I
That
know
whole
it's not
that
that-
whole
well,
mushroom
that's
trip, that was the best.
Yeah, Jeremiah, I was like, you were on that day, and then I was out. My old lady had put her cup with water beside where the router was, and the cat jumped up and right into the router. I watched it pour in and it go.
Oh man. Yeah,
So
you just like
there's-
it's like in slow motion. You're just seeing this splash, and you know where that
You
water is
can't
gonna
run
go. You
over
know
it,
what it's gonna do
you
to the
know?
board when it hits it.
Yeah, it is what it is. That's why that joke was perfect.
No,
I gotta do a temporary shout out to Sean Calderon
Yeah.
and Pineapple Owl.
I'm sweet. I got a beat. Just look at me. What do you see? Pineapple owl. I'm a pineapple owl. Pineapple owl. I'm a pineapple owl.
So what did you call the other one that was completely inappropriate?
Pineapple owl. I'm a pineapple owl. I'm sweet. I got a beat. Just look at me. What do you see? Pineapple owl. I'm a pineapple owl. Pineapple owl. I'm a pineapple owl.
That's so great. That was
So
awesome.
bad.
Bernie.
Sorry, you brought it up in the comments, so I just couldn't resist playing.
I like the beat.
Yeah.
See, that's good AI. That's AI doing good things.
Oh, you want to see some non-AI?
Ish.
Sure.
Even better. Yeah.
Oh, hold on. Give me 1 second, because we're gonna have a little fun right now. I'll pull it up. Because we have to honor the fact that Gerald can't draw a circuit.
Episode
I
4.
can draw it. It just doesn't come out right.
Gerald, this is your cat speaking.
Oh, epic
For
episode.
main engineering. We're having a problem with the circuits in our main deflector dish ever since we had the remodel.
But again, not every coil works with every circuit, like you said, right?
Yeah.
You have to play with different circuits in your coils to get the system properly running.
Okay, Gerald, why don't you just step up to the whiteboard here and show us exactly how this circuit's supposed to work?
So power source,
No way.
battery, the positive goes to the
Oh, hold on.
the negative goes to the coil, right? Signal generator, positive goes to the base, negative goes to the emitter. Now that I used for a regular pulse, but I drew it wrong because I was drawing. I know what I did wrong here.
Yeah, Gerald, this circuit doesn't look right at all.
I apologize, everybody. What I drew here was the circuit with a horizontal deflecting transistor, and I will just change it really quick. Okay, so yes,
Like
like
I'm
this,
dying over here.
like this. You should have left it open. Let me fix that.
You're still thinking about that circuit, aren't you?
No, when I drew it,
Oh,
right?
you do it again?
Clear out
Not
the
really,
circuit.
but
It's
kinda.
inappropriate to view.
Gerald, I'm so glad you got that circuit fixed. Man, the additions that you made to the front deflector dish really look nice.
Oh, it's horrible. I'm a horrible person. I apologize, everybody.
Amazing.
That's freaking great. I
Amazing.
howled the first time I seen it. I was like, no!
Did you notice the batteries were double D's?
No, I didn't notice that part.
Yes, I did. That's why I was cracking up so hard, man. Unbelievable.
Oh,
That's awesome.
That's so great. Hold on, let me find it for you. Because you can see both of them, man.
Oh,
Oh yeah.
neat.
Nice. Oh, I
Oh,
love it.
Yeah, and the
Oh.
way that you finish the show with that last image, that really nails it, doesn't it?
yeah.
The
Right?
Star Trek series, it's gonna go gold.
Oh, dude, that's so
Oh,
hilarious,
that's
man.
perfect.
It's gonna need a golden bra if this keeps up.
Oh, did you see Bernie when we're all tripping balls, dude, on the shrooms?
That
Oh,
one,
yeah.
I haven't seen
I
that.
love it. Oh,
Oh, hold on. I'll put
Jeremiah,
that-
you're missing out.
Yeah, these are hilarious.
It started out with me being corn cob in the episode before, and then we found the magical cave.
Captain speaking. Joe, can you please report to the transporter room? We need to go back to the planet where you found your strange rock. Bernie's going to meet us down there. Mike, transport us down.
You have three holes. One is ground at the bottom, and the two that are at the top are the power. Are they the two holes? Are they the same size, or is one bigger? Put one prong in the ground and the other prong in the smaller hole. That's your hotline.
Is he daydreaming again? Hey, Mike, transport us down to the surface, please. Okay, Joe, where exactly did you find this strange rock?
And I could sense it. So like I'm very attuned to it. I could like sense it as soon as I like start fumbling around with it. I'm like, up there it is, you know.
Well, let's keep moving down the river to the cave where Bernie is. Oh man, look at all these magic mushrooms.
All right.
Go
All right.
These things?
Psychologically, you know, having high amounts of that crap around wasn't the best for me. You know, like it would, you know, always kind of grab me, and I'm like, oh yeah, all right, that, you know, and this kind of did that, and it was very, very intense, and it wasn't bad.
Well, after careful consideration, I say we eat some of this stuff and see what happens.
Wow. Instant brain fart there.
Are we still in the cave? Why is everything moving? What's going on, guys?
Direct departure. You know, the 90% of the brainwashed most senior epic legends and pillars.
What the hell did he just say? Oh my God, tripping balls, man.
You know, I'm deep into meditation, you know, and you know, some different spiritual aspects and stuff like that of you know, metaphysics, and you know, I could tell you, I mean, these things they do have, you know, psychological effect, you know, as far as that stuff goes. And
My lips aren't moving, but I'm still talking. Must be an inner monologue. Awesome. We want to turn it on. We want those effects. We want our mind to work the machine. You know what I mean?
Mhm.
So we can figure out how exactly to do it.
Spinning the rotation aspect, that is now one dynamic of open system adding to it.
so it's like, oh well, I mean, what's the difference? It's like, because things don't do this.
Yeah, that's why.
That's why. You see, like, yeah, it's subtle. You're running your finger across something and you're feeling it starting to skip on the surface, but it's smooth. You know,
Yeah.
It's like things don't do this, and this does this. And yes, it's subtle, but it's there. You know, but then there's the more extreme examples. You know, like the thing, you know, taking a lift off. You know, and it's like it just slipped out of your hand.
Oh my God. I can hear Joe in my head and Bernie in my head, but their lips aren't moving.
And then
Which
it's like, so you
isn't
add that
at all.
You know, you
spinning
push it this way, it
to
goes that way,
other
you push it this way,
aspects,
it
like
goes that
bringing
way,
in
and
radiant
the thing
energy
isn't going to
from the
exert
environment,
its own
like if it's
force
endothermic
out
cooling
of my
or from a
hand that
plasma,
you can
right? All
feel
these
on your
other
hand.
aspects that
You
you
know,
start
like,
combining those
this was
dynamics
doing
of extra energy
was forced
in,
down
that
like a
you're
sack of
able to
potatoes
get the
to the ground.
exponential gains
and I
in your
couldn't move.
systems.
You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes.
Oh my God. There's no more holes. There's no more holes. There's no more holes. Mike, beam us up.
You're right, Nathan?
Yeah, I'm living right now. I'm barely breathing. I kept a big bottle of shrooms, man. That was great.
I quite enjoyed that. I enjoy all
you
of
gotta
them.
laugh, man. You gotta laugh. Life is too short.
Oh, they're amazing.
Oh my God.
But
Oh, we have too much fun on that thing, man. Oh,
Jeremiah, what were you teasing with while that was playing?
oh.
Aha.
The nipple.
Yeah, that exchange, man. I'll tell you. That's a hell of a thing. So no, I was playing around with the redesigned Quincy system. So we have this. Well, I better take it out of the bag so I can actually show it. I've showed it before. So this is an electron emission ring. It has a sharp edge and a smooth contour on the inside. And there is an asymmetry in the angle. As you can see, the bottom side is slightly shorter than the top side. Well, that perfectly conforms to this particular geometry here. And so this is the geometry that the ring is based on. And ideally, there's a separation point here, but I'm just testing the basic physical structure to align the magnetic fields. And now, this is a magnetic indicator. On the inside of this, I'll show you what's inside of it in a second, but we can see that the angle of the magnet here, as we move it up and around, we've got the south pole on top. And our north pole on bottom. And what's really cool about this design is right now I just have a set of permanent magnets inside to create the field geometry, and I'll explain why it's important in a second, but I can twist this by hand and just pluck these two pieces apart. So here are the stack of magnets on the inside. And these clips allow me to open this chassis up and close it. Again, this is another brilliant part designed by Simon based on my crude drawings that I gave him. So the idea is at the exact angle where the magnetic field flux lines are completely orthogonal to the electric field pressure of accelerating electrons being emitted from the edge, that the electrons will end up creating a cyclotron motion around the edge and produce a photonic emission, which will modify the space-time refractive index. So what we're doing here is effectively trying to pump the space-time with a huge amount of very long wavelength photons emitted by Bremsstrahlung radiation. And by doing that, we hope to affect the space-time refractive index, thusly changing the speed of light and allowing us to accumulate localized energy much above what is considered to be the entry-level limits based on conventional mainstream physics. Did I just lose everybody?
No,
We're here. I thought Bernie was going to put everybody back on, and we're all sitting here in the back just looking at you. Oh, man. So basically, you're going to spin it really fast and see what pulls off of it, right?
No, actually, it doesn't
Sorry.
rotate. So what happens is electrons fly off the edge. They experience the Lorentz force as a result of the magnetic field that is in the center of the craft. The magnetic field is completely orthogonal to the electric field that accelerates the electrons off the edge. So instead of taking a straight path, they'll take the curved path that is produced by the magnetic field. And as a result of taking a curved path, instead of taking a straight path, the amount of time that they take to follow the same straight line that they otherwise, would be following without the magnetic field is called braking radiation because they're taking a longer period of time, so they radiate off the extra field stress as they rotate around. And this is effectively how photons are produced. It happens interatomically very easily, but in this case, we can produce free photons in the same way that synchrotron radiation works in the open atmospheric environment surrounding the craft. You know how Alexei's seen strange orbs and other weird light? Well, some of that could be Bremsstrahlung radiation.
Yeah, I can prove that in my epoxy right now. I have problems. I can't use my big coil because I've captured what seems to look like EVOs that have been growing as I pulse the systems.
Very nice.
It's nice, but it's a problem because when before I put it in epoxy, they weren't being contained. Okay, so they were just going into the environment and at certain frequencies. Well, we can't get into that subject as to what they do, but being in epoxy and being held there stationary, be growing, I don't know exactly what the outcome of that would be in hand. So, is it good? Is it bad? Not really sure yet.
So hold on. Are you not spinning that thing, Jeremiah?
That's right.
Okay, and it's stationary, and you're not putting any energy into it.
Oh, there's plenty of energy that's going to be put into it.
Okay, so
The entire outside ring is charged with an extremely high voltage.
okay,
The high voltage creates the electric field component. The magnetic field component is originally prescribed in John Quincy Sinclair's patent applications as being powered by a very high current electromagnet. Now, I'm not going to use an electromagnet in this case, except for a very small one that surrounds the ceramic magnets. And the nice reason about them being ceramic magnets is they have no conductive shell, so no eddy currents if I need to change the field geometry. But I can basically use the ceramic magnets as a permanent magnetic field source to produce the net flux, and then it'll require me less than 10% of the energy to produce the necessary magnetic change in order to control the field geometry.
so hold on. What's the shell doing? Is it repulsing the field at all, or is it creating a field around it?
Yes, the
How-
shell is pulsing the field at the very edge. It's repelling the electrons away from the edge at a completely orthogonal angle to the magnetic field lines,
Okay,
which causes them to take circular motions. Then eventually they will stray away and try to connect with the hull of the craft.
and you've already got it to flow on this, because I've never gotten it to go on plastic like that and flow.
No, that's just an early. You're just looking at basically the sanded prototype without the metallized edge.
Oh, okay.
It's
Okay.
finished, you'll see a metal edge, and that will have a very sharp point on it, and a corona ejection ring, which will produce the electron flow necessary for Bremsstrahlung radiation.
Okay.
So
That-
you're looking at
That's where I
it.
was lost. Okay. I was gonna say I spin plastic all day and it doesn't hold any field. It's kind of junk when it comes to this stuff.
No, that's just a frame.
Oh, but what if you nano layer like a foil metal of like
Then it'll
gold?
start to change.
Right, which is exactly what we're going to do.
Yes,
I don't
that's what I was thinking.
Just
Okay.
that we may try even using gold leaf because it would be extremely precise, but that would require the
Some of that.
surface to also be extremely smooth. And gold leaf is a potential solution, but I would prefer a razor blade edge, something that's made of much harder, higher temperature material.
No, you got to look into the guy that made the ion lifter, where he actually took the plastic and coated it, and it came out like copper.
Not sure which guy you're talking about.
He wears suspenders, and you always see him connecting with plasma channel. But he has a process where you dip it, and it'll actually coat it.
Talking about Intexa?
I don't know his name. He hates tomatoes.
He
That
hates
guy.
tomatoes. Yep,
That's in Texas. Yeah.
Yeah, that he coated stuff with it, so I don't know how helpful that'll be and how smooth it'll get. I would imagine it's rough, but at least it covers the plastic.
I consider the approach. It is a possibility, and I might very well end up doing something like that. The problem is the seepage into the individual lines of our 3D print might cause us to deposit metals where we don't want them.
Go over to a shop and get a aluminum and have them work it out with the lathe, and then put your magnets inside of it. You'll get a nice, perfect connection.
Indeed, that is another possibility, but for now we're just testing the field geometry. So, like I showed, you're looking at the very beginning of just testing the magnetic flux.
Gotcha.
And so, in terms of controlling the electric field precisely, that's something we haven't gotten to yet. And I think it won't be that difficult to achieve. But for now, I'm just going to test the field geometry with the basic structure of the craft and see if anything needs to be modified there. And if it's good, which it looks like it is right now, then I have to consider how I'm going to get the electric field and prevent arc over.
So 1 foot in front of the other. Gotcha. That makes sense.
Yeah, one step at a time. Just like you, man.
Using your load would, or using a load would stop your arc over in a way. Depends how you're doing it. Your system, I don't think it would work like that.
No, it wouldn't, because here we just need pure potential in order to radiate off compared to the net external environmental charge electrons, free electrons that can then cascade and start to circulate. So we want that cyclotron motion in the magnetic field, and for that we do need emission of free electrons. Now, there is another possibility. I could surround the edge with a hot emitter. I could use, for example, little ceramic posts or a ceramic ring and put a thin tungsten filament wire on that and use it as a hot emission source in atmosphere, and that would produce a plentiful amount of electrons at a very low potential. The problem is, in order to produce more brimstone radiation, we want actually a much higher velocity for those electrons. So if I emit them with a hot cathode, they'll have a lower velocity because their emission pressure is much lower. You know, the requirement is much lower thanks to the heat. So if I emit them at room temperature or below, they'll have a very high velocity. And because your Lorentz transform depends on the velocity of a particle versus the magnetic field, the higher the velocity, you're going to get this higher curve.
What was that?
I do not know, but I heard it.
That's so weird.
Sorry, I had
Oh
my
my
mic on.
Like dog.
Somebody lost their dog.
Oh, okay.
Good Samaritan. Mike trying to save a dog. Good on you.
So on that field geometry, I'd put a Tesla coil right in the center and spin it, and then open up the center and let the energy flow through it, and watch how cold it gets in the center. Because spinning a Tesla coil is different than putting something on a Tesla coil and spinning it.
Okay, let me ask you this then. I was recently inquired about this from a fellow researcher about the idea of spinning Tesla coil secondaries while keeping the primary stationary so that there would be a relative difference in terms of the two reference frames. It was also proposed that you could spin the entire Tesla coil. I've already done that and nothing happens, but spinning the secondary relative to the primary might produce longitudinal waves. At least that's the theoretical concept. Now, in my model, it shouldn't really do much of anything. It should produce ultra low frequency longitudinal waves, but I don't see the significance of it. Now, maybe there is significance. So I figured out a way to do it. Figured out a way to spin a Tesla coil secondary at almost 2,000 RPMs relative to the primary.
Go on, I'm listening.
And if that was something that anybody thought was significant enough beyond just the little stream of thought that someone else had about the idea, I might be enticed to put it together and show some video of it operating.
It's because you haven't introduced a secondary field to the Tesla coil field that you're not seeing what's going on. Because it'll look like it's doing nothing, but you have to put in a static field or something else in order for the Tesla coil field to move it. See, that's the differences right there. You have to introduce a secondary field. So when I do it on the Gravity Flyer, so let me remove this off the screen because we're getting a little far before that. I don't even know where that's coming from. Thank you. Can you please remove it? Yeah. So what it is, it was just, okay. What it is when you put the Tesla coil and you attach it to the top and bottom disc and you run it from the top of it all the way down to the bottom of it, you create a field that's able to push out. When you put the center of it in static electricity, basically what it'll do is it'll create the static electricity that forms right around the bubble that the Tesla coil is building. Then the rotational speed will push it out. You can also amplify it by the amount of power you put in your Tesla coil. I generally run the same amount of power in the Tesla coil, but the amount of speed will push it out, bring it in, push it out, bring it in, depending on how fast you run it. And you'll be able to create a field line that'll show up when you put a light bulb next to it, and you'll be able to see when they're starting to interact very much together and cross, and then when they're far apart. And you'll be able to put the distance of your field in that. So that's where the magic starts to happen right there, is you have to be able to take one field and push the other. And if you don't introduce the secondary field, you won't be able to push it because there's nothing there to push. It'll just react like a standard Tesla coil. The difference between a standard Tesla coil in static form where it doesn't move is the amount that it can force in and out. Like it'll do it in that way, but then it'll have tons of leakage. And that's not what you want. It's not thick enough. So you have to rotate it to get it thick enough in order for it to move the secondary field so that it creates the right movement.
I can see the stacked fields, and again, this was one of the things that I was talking about with that geometry that I showed, the Black Photon Spacecraft by John Quincy Sinclair. You've got to have them completely aligned, and the fields have to be balanced out. And so, in the same way as the Graviflyer, if you want to accumulate energy, you have to have balanced fields. When you did your experiment and you accumulated energy by basically reversing your poles and getting rid of the negative pole, grounding it out, and using only a positive pole on the center plate and AC on the top and bottom rotating plates, you accumulated energy and you had a release of that energy.
Yeah, but the grounding didn't ground it out like get rid of it. It wasn't getting rid of it because you're putting a ground into your Tesla coil and you're putting a ground at the Gravity Flyer, which connect underneath the earth and actually create a field under it. So
Right.
then
Well, I don't mean that it's
you're
just
gaining more energy.
It doesn't disappear. No, the energy never disappears. No, it gets stored. And
Yeah,
so
but you're pumping that energy with that Tesla coil with those two fields under the ground. Therefore, It's accumulating more energy in your Gravity Flyer.
right, so you end up with a net force between the two systems. And so I didn't mean get rid of the energy,
Okay.
as in destroy it. I meant get rid of it out of your circuit. You're pumping it into a tertiary circuit that is your Earth. And
Okay.
by pumping it into the Earth, you're removing it effectively from your circuit, and now it becomes part of the resonant circuit of the Earth. And it does accumulate locally, more so because you have resistance in the Earth Earth crust. And the high resistance of Earth crust means that you tend to accumulate charge. So say, for example, after a lightning strike, you're going to have the net charge of that lightning strike left over in that general region geologically for some period of time until it has a chance to dissipate.
Well, that's kind of the reason you have anti-gravity, isn't it? You have a field below and you're creating a field above, and then you're
Right.
counteracting the fields and it lifts.
Right, and then that's how the Graviflyer flies.
There you go.
That's how a lot of these systems operate. But the way that they actually achieve the energy levels required to produce the necessary electric field intensity is rather peculiar. I mean, it's very unintuitive.
Well, it's creating a megahertz frequency in it when it creates the ring. That's why it's done that way in how it's being built. It's going from kilohertz to megahertz, and then it goes up to a couple hundred megahertz when you hit it, when you amplify it with a piezoelectric disc. There's a massive amplification that comes out of this thing that most people aren't realizing because they don't see it when it's connected correctly. They put it incorrect and they hit a dud. They don't align the fields correctly. They don't put it in the correct configuration to accumulate energy. Like I was talking about the cones, and we were all talking about the shift. As you shift it, they move where it aligns properly with the actual vortex of the field. Then you're able to get what you want out of it. Most people don't get there.
Yeah, that's true. And aligning the field geometry is extremely difficult. Alexei tried to specify when he sent Charlie C his kit the dimensions, and they made their best effort to align them. Unfortunately, you know, Charlie's kit showed up with broken magnets, and he replaced them with ones that looked basically the same. But allegedly now there's this whole controversy over whether they were the right type of magnets, and I didn't even want to get into it. But it you can use whatever type of magnet you freaking want. It's just a matter of the distance, and so the electric field versus the magnetic field are really all you're looking at there.
Well, it matters because you're killing the point of saturation in the center with the magnets that you're using. You're over amplifying the center to create heat in it, so it doesn't allow it to get to the point of saturation because there's too much heat. You need it to be a different field. Okay, it has to be a dielectric and then it gets saturated.
I'm not saying that the type of magnet doesn't matter in terms of the spacing. Obviously, the spacing is completely determined by the type of magnet. What I'm saying is the type of magnet doesn't matter in terms of the function. You have to change the spacing when you change the type of magnet to compensate for the function.
But it matters when you have your top and bottom plate and they have to connect together and they have to pull the energy together in a field. In order to do that, you cannot put certain distances in there that are too far away. You have to keep it as close as possible that you can. Once you put it too far away, they will not connect the top and bottom field, and you will not get the saturation in the center you're looking for. That's why you're overpowering it, and you're just blowing it out. You're taking the cold electricity from the center of the Tesla coil, and you're heating it up. So therefore, you're creating an explosion in there when it's working on implosion in there. You don't have enough cold energy in there. You have too much hot energy using the cold energy right away. It's like setting off a line of firecrackers instead of just, you know what I mean, creating a cavity where the cold energy can get colder. That's the problem with the neodymiums. They're too much heat. They just completely annihilate the whole concept of why you want this thing to work the way you want it to work.
Yeah, but it really looked like neodymiums that came with Charlie's kit, and it looked the same way when Russell got his kit.
I could tell you right now when the way that it works and the way the fields go and how much time I put into this, neodymium is the wrong way to go because it's just too much heat. When you get a ceramic magnet, you're not as much heat, and you'd have to do both experiments to see it. You don't want all those eddy currents in there.
Do you think that Alexei changed out the magnets before he sent out the kits?
Oh, he probably changed out the magnets and he changed the circuits because the circuits are wrong compared to what you need. They're bad circuits. He just pulled them from a book. He said so in one of his videos. He said, well, they wanted a circuit for this, so I gave them, this circuit here. Well, the problem with that is you're not grounding your Tesla coil. When you don't ground your Tesla coil, you can't create the field underneath. That causes a whole problem because you're in a Slayer exciter. 90% of people do not ground a Slayer exciter. You know what I mean? Because they don't know that they can. And when they do, they tend to blow them up.
Dude, running a Slayer exciter without a ground is kind of insane.
Well, dude, they do it all the time. You haven't seen these videos everywhere?
No, I've watched too many of them. Honestly, it's a bit of a heartbreak. I just stopped. I don't want to lose faith in humanity because I think that there are smart people out there and that they're plenty, and I want to believe and continue to believe that the world is intelligent. But when I watch some of these videos, I lose a little bit of faith in humanity, and I try to avoid doing things that assist in that overall process of losing faith. So I'm sorry to say it that way, but yeah, I don't watch a lot of those things because there's enough stupidity out there as it is. I mean, good God, do we really need to push it farther?
Well, see, now if they learned their lesson by what Alexi actually did by putting that wire down that Tesla coil, they'll start to understand how Wardenclyffe putting the pole down there goes down to the water underneath into the water table and why you want to put it in there. So you want to look for Tesla's third type of energy. So when he went to a trip, I believe it was in France, he put his equipment in there and he lit up like a light bulb, right? All kinds of like purplish blue color all over his body.
Yeah.
Well, that same effect comes from your Tesla coil when you put the wire down the center of it. You create that cold electricity, which is actually what made him glow that day.
That's the same effect that happens in the neon in my coil all the time.
Yeah.
That new transistor, it shows up every time I turn it on. It's crazy.
So if we use that type of technology like Gerald's doing, like the Tesla coil's doing, now you start to understand where he was going with it and why energy can be transferred huge distances through the ground, not through the air. The air is explosion. We don't want that. We want it through the ground. We want implosion. So that's how you have to connect it and understand it. And until we get to that point where we can saturate the ground right there, I mean, I don't know a better way to tell you guys, but we're not going to achieve what we want.
Yeah. So in my experiments, when I created a very high oscillating electric field, which technically is producing longitudinal waves, and I placed my hand very close to the emitter of that electric field, I felt a significant heat. The emitter itself did not get hot, and neither did my hand, but I perceived the sensation of heat.
Right. Well, that's Mike. Gravity fire in the center is 20 degrees cooler than ambient air, but the outside will burn your finger.
Yeah. I did an
That
experiment
ambient
with
heat,
aluminum
though,
plate.
that sorry to interrupt, Gerald, but it reminds me of the heat I'd feel with this thing when it was fully intact at the bottom. Like it heats up your hands so quick. It's so weird.
Yeah, I remember that one. That was a really, in fact, Bernie, I don't think you ever told.
No, I did rip it apart for you. That's why it doesn't work.
No, you told me. You told me. I don't think you ever told me.
Oh, by all means, explain.
Oh, it's actually, I can feel it heating up right now, even in my hand, still like this. Wild.
And that's torn apart. So
Yeah.
originally, Nathan, what you're looking at there is, and I'll kind of prep his story with a intro. He had this thing perfectly covered in foil.
Okay.
It was built on a base idea that geometry could somehow harness energy, and it produced a heat in his hand that was
It
so
still
hot.
is right
was
now.
originally covered, right? That it that you couldn't hold it when it was fully coated, right? And you had handed it to several other people that visited you, and they also couldn't hold it. So tell us a little bit about what this thing is, and what your idea.
Literally
about why it might be
just
doing this
copper wire, I think 14 gauge maybe, and aluminum foil built off of a tetrahedron, those 3D printed. And yeah, it's like, wow, my fingers right now are even like getting all like tingly and stuff from holding it, and the palm is still heating up, right? It's quite a sensation. But yes, you're correct that several people friends of mine that came into my house, I would let them hold it, and most of them would end up dropping it and be like, what the heck? And like I would make sure not to allude that it was going to be hot or heat up, just to get like an original reaction and make sure that like I wasn't imprinting the idea on them or anything like that. And the one anomaly was anyone that had been drinking alcohol would like just be completely numb to the effect and like not notice anything at all. And it's like, it was very strange that way. Very, very interesting.
That's cool. I like that. So basically, is it just wire on the inside and then you put all the foil over top of it, and it's produced in the field?
2 layers of copper wire woven in triangle manner, and then aluminum foil on top of it twice.
I must try that.
I recommend it. But I
That's
connected all of the triangles like back up to the top, so it's like they're all wired to like one corner.
So do you think the energy is pulling through your hand from the ground?
Possibly. It's like some sort of antenna. And
Well,
yeah,
they say
it's like,
pyramids pull water from the ground, so that's why I'm asking. Do you
Well,
think
one
the
easy
energy
way to
pull?
find out is, be holding it in your hand
and it's the
and then
left
grab
hand.
hold of a water
Sorry.
pipe.
Another crucial part is it's the left hand that you feel it in. The right hand, it's not nearly as much. It's it's peculiar that way as well. Very, very peculiar. Just
That's
to throw one more oddity and wild claim in there.
I'm gonna try it.
Please do.
Definitely got to try that. Triangle and another triangle inside of it, or just
Yes, it's a tetrahedron, triangles within triangles within triangles. And the crazy thing is like on Periscope channel maybe or something like that, it's like some old Navy 50s movie of how to make a crazy antenna, and it's like it was the exact same like thing out of copper, and it was weird. I saw it afterwards. But yeah, that's the story of the copper aluminum pyramids.
cool.
Yeah, you should send us the dimensions and the file for your 3D print.
My
To replicate
friend
it.
Isaac has that. I will have to get a hold of him.
Please
Shout
do.
out Isaac if you're watching.
Right on. Gerald, you there?
If you're trying to
Disappear?
speak, you're muted.
Yeah, I just came back from the bathroom. Sorry.
Oh, perfect.
You were talking about your coil and what you were producing out of it?
Oh, the cold. Yeah, I did an experiment with aluminum plate underneath, and I grabbed it at the wrong moment, and it felt like I got a shock. But I got so cold that I had the shivers for an hour. So yeah, when you're playing with temperatures, it makes a difference. So you got to understand how all that works.
It like
Yep.
sucked the energy out of you, hey?
No, more like it sucked the heat out of me and
Heat.
planted the cold on me, if that's the right term.
Okay, yeah.
Gotta watch the way we say things around here. You know what I'm saying?
I mean, heat is a form
I
of energy.
feel that. Actually, I get sometimes I get a very similar sort of like feeling like just in the room when I run some of my electrolysis coil experiments. It's very strange, but it's just like I just start shivering, and it's just like you just get freaking cold. There's nothing you can do.
When I get shocked, it's a rule in my house that I gotta go up and tell my wife, right? Because if I have a heart attack, if something happens, and I got shocked and went and told her, and I'm shaking. She had to put a blanket on me, and it was insane because it was like 28 degrees outside Celsius. So
Yeah,
it was
so
hot, but
right, so like literally the middle of August and July, it's like it'll be 30 degrees out, and I'll be in my basement shivering while I have like the monoatomic gold going, or like a bunch of like the hydrogen being made. It's kind.
oh, see now hydrogen, that's another story. But yeah, you could be doing something similar.
And but then okay, so a different but similar phenomenon was the one time I experimented with making monoatomic lead, and do not do that because it will make you dead. The lead makes you dead in the monoatomic form very quickly. But that when I ran the experiment making the monoatomic lead overnight in my garage, it's like when I like fell asleep like in the opposite corner of the garage on like my couch, and I woke up and it's like that I just felt like the most heaviest energy weight, like holding me down, as if there was like the physical weights on top of me. And it's like my dog was the exact same. Like it was like the poor thing, he was towards the end of his life at that point. Like he almost died that day. I swear it was wild. And like just it physically sucked like the energy, like I'd say almost like the chi out of like life, out of energy out. It was wild. But
The only time that happened to me is when I went to the building downtown. I talked about it before, and did the thing with the flute and the rotunda because it's a perfect replica of Solomon's Temple. And then I had that happen to me. It took me an hour just to get up enough energy to get on my bike to try and bike home. It's just insane. But you know,
So you have to tell your wife every time you get shocked?
when they're major shocks.
Oh, I was gonna say I better have my
say
wife in
all
the
of
next
you
room.
should have that rule.
Shit. Not in my house, man. I'll be calling her every 5 seconds.
Well,
They'd be
yeah,
like,
I know.
"Whoa,
Regular
oh."
shock, I get shocked all the time. But when it comes down to like stuff that's heavy, then I'm like, okay, what the heck just happened? I gotta tell somebody because you
Where
never
it
know.
leaves you shaking.
That's
Well, I
heavy.
was literally like as if I just come in from -5-degree weather in underwear. So it didn't make sense why I was cold. Not until later, and I thought about it, and I was talking to Nathan, and it just went click. Oh yeah, right. It's the same as putting a lighter inside my coil when it's running and the voltage goes up. It's just playing with temperature, right? It's all it is. Except that was the one that was the temperature.
Does your voltage go up or your amperage go up?
You could say a bit of both, but it shows up as voltage on the meter.
It's interesting.
Yeah, I'm gonna show that on video. That's the other video I had to do. I got a couple logged I haven't shown or put up yet, so I'm gonna write that down so I don't forget, because I will.
I feel you. It's never ending like list of work and projects. It's the
That's why I have
list you
so
got.
many notes. That's why I do the scientific method, because otherwise I would have forgot the last experiment I did at 11 o'clock this morning. I just do so many, right? So it's like, you got to write this stuff down.
Well, look at how cold energy is done. So when you get a cold energy circuit, right, you have to take a light, and it can't just be an LED or something like that. It has to be a light with those little fuse-like things in it, those little filaments, okay, like a car light bulb or something. And basically what happens is it'll suck energy over to it. So there's a path of least resistance. It stays on the hot side. But this cold side, you put it in, and it'll pull the energy towards it into there. So if you got that kind of effect going on there, you're going to be pulling cold energy into it. So whatever system you got running that's cold, you're getting it pulled into you. Kind of an interesting, it's an interesting way to look at it if you actually look at how the circuit's built.
Yeah.
So another interesting phenomenon I experience every time like I accidentally touch a bunch of like the monoatomics or even like the diatomics, like the oxides or whatever, which you should never do because you get heavy metal poisoning because it's nanomaterial and instantly absorbs through your skin and through your cells. And because it does that, then you have all of this crazy charged metal material in your fingertips. And it's like, I literally, every time that happens, it's like the wildest, as if I've been like charging my feet on like a carpet and like pillow and like whatever, like just a giant static charge every time I touch metal after doing that. And it's like, it's wild. It's, I don't know. I don't recommend it.
I can't, when I did my lighter experiment, I can't hook the lighter to the coil because if I do, everything I touch in the room gives me a shock. There's a way of hooking it to the casing of the lighter, and it literally shoots electrons out like there's no tomorrow. Like,
Shoots
it's
electrons
insane.
out like the cold electric video we showed the other day. Is it like a pew 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 thing?
You know what? I didn't see that one, and I actually missed that live and everything. That was Friday night, wasn't it? Like
I
that was
believe-
yesterday.
No, it was
Yeah.
like
You
What
just
was-
did a Rumble only stream on that, yeah.
yeah, that was the Rumble only stream. That was Wednesday, I think. Or
Yeah.
Wednesday. Yeah, missed that one. I think mentally, you know. I missed the thing with water that you showed. I wanted to look at that because I actually have an experiment on my desk. I'm just getting ready to.
What was going on with the water? Which video was it?
Bernie, was that your video? That was there was a light
I'll
bulb.
bring it up.
wired
So yeah,
over.
the one that we were playing, and it's also the one.
Oh,
that
yeah,
has
yeah.
the same effect.
Yeah.
Okay. That I remember.
That might have been the
Oh,
video that
Jeremiah,
actually.
I wanted you to see this. So well.
There's an old YouTuber out there by the name of Mr. Angus Wangus. And he
Angus
uses
Wangus.
Tesla's hairpin circuit. I know he makes fun of it himself. Okay, but Mr. Angus Wangus, okay, and he uses the hairpin circuit, and he's got the light bulb light, and he's got his fingers in the bowl of water, you know, with the spark gap.
Oh.
Electricity, right?
So Angus Wangus, huh?
Mr. Angus Wangus. I know it's still on YouTube. I looked at it last month.
So you talked about circle jerks and Angus Wangus, huh?
Mr. Angus Wangus, man.
You sure is. Ah, sorry.
Gotta have
Oh, I love this show, man. Oh, so many fun moments.
So many clips, and just so you know, Nathan, I hit like the clip marker for each one of these, so you can go back in like the StreamYard editing, and there's markers for each like clip that you know are good for Star Trek and the rest of it. And
You know, I barely got to learn any bit about the StreamYard editing part. I didn't even know they had it until you brought it up.
all right, well, I guess I'm gonna have to teach you that another time.
Hi ho, Timothy Brock here, coming to you from Sesame Street News.
Look at Gerald.
I just had.
I
I had
love
to.
Kermit.
All right,
Oh.
there you have that one for the next clip too.
Oh my god, dude. I can see it now. We're gonna be in there with freaking Ben and what's that guy? Letterbot?
Yeah,
And
and
we're
then
gonna
the
be
pineapple whatever.
why were Angus Wangus and Circle Jerk?
Yeah,
Oh my god.
gotta have fun.
Oh,
Angus, Angus, circle jerk, 3 holes, put it in the little one. Is it hot? Wiggle it around. You got it. Beam me up, Scotty.
My brain just went no.
Mind blown.
oh,
You know that's going in one of them, Bernie. You know it.
oh, I always do that. All right, because that's how Bernie opens all of his shows.
All right.
There you go.
Oh, that corn was the best, though, man. Oh,
I love
every time I have it on Facebook, it says corn something, and I'm like, what the f- is that? And I'm laughing my butt off, dude. So I had to put it in there.
That's freaking great, man.
Oh,
I
love
showed
those-
that to my
those Star
girlfriend,
Trek
and she
series.
laughed so hard. She loves it. It's like we all love it. It's amazing.
well,
Yeah.
because everybody was talking about something totally off topic, right? And I took the whole subject matter out of the topic, so it just sounded like a bunch of random stuff. Oh, so great.
I like that. I like the part where
Exactly. It was
Joe's in your
beautiful
head,
trolling.
so-
It was amazing. We
hey,
gotta
Joe and
troll
Ben's
it.
in your head.
So which one did his head?
when Joe was in your head, you're sitting at the end of it there, right? You can hear them both talk. It's just like that was funny.
I don't know if you ever had those kind of experiences, but I have.
Oh yeah, yeah. More than I care to explain, actually.
I just gotta tell myself it's not real. It's not real. It's gonna go away. It'll be all right later.
Yeah. Happy place. Happy place.
That's right. Oh, that's so great, man.
I got more videos coming out. I've been doing some in the last 2 days.
Right on. Hopefully, it's your presentation. That's
Yeah, well, that's the thing. My issue is, okay, so when I do videos, you see them short, right? There's no, I don't write a script. I don't practice. I just do a video and that's it. Like from beginning to end, and I put it out. I don't even edit because I don't have my editing program's out the window. So when I get that from you, yeah, I'm going to put my presentation out. No more waiting.
you'll be in that editing for a while, man. It takes time.
I've used NCIH before. I used to be good at it, and then I
Good.
lost it. So I should be able to remember how to use it all again.
All right, Bernie, you want to blow up that experiment and show us what's going on?
Yes, fry it and find out. That doesn't
All
look
right.
That doesn't
I
look
think
right.
my computer is frozen. All right. Can you hear me?
Yep.
All right. Maybe we're not frozen. Oh
You keep
no.
doing it.
As it's not responding.
Your computer die on you. Oh,
You need a new laptop, Bernie.
I remember this last time. Your computer was freezing on you when you showed it the first time.
Natural.
It was like a
conventional
special effect.
electricity. Pretty simple. So one of the things that I'm going to show you here is that this electricity can work in many different ways. One of the things that I want to show you quick is this cold electricity.
Okay, I paused it for a sec just to give a little bit of context, and that one of the things I've noticed, the big thing is there's a spark gap at the very bottom, and coming out whenever he turns the circuit on, and there's a plasma arc going through the spark gap, coming up, shooting up across the entire screen, going up, are these some sort of like particle bubble things. It's very strange, and I've seen it a few times in a few different things. And then it's also the fact that he's got the cold current and it's still lighting the circuit, igniting the circuit through the water, and it's not even salt water, it's just tap water, he says. Puts his hand in, doesn't get shocked. So a few different anomalies within this.
Can obviously just light a light bulb.
Wow. That feedback noise.
But
I don't know if that was from.
Thing about this cold electricity.
Yeah.
Light a light bulb.
Right there at the bottom.
Now,
Yeah,
to
it's
anyone who looks at
considered
this,
water.
they would say, "Well, that doesn't. This is just water straight from the tap. Nothing special about it." I'm gonna dip those in there. So now the whole thing is submerged in water. What happens when I turn
I
the cold
think he's-
electricity on?
Yeah. Oh man, that's so cool.
Pretty interesting, huh?
Yeah, there's a video on Instagram of Daniel Nunez doing something
say, okay, well,
similar,
that's just a
putting his finger in the
fluorescent
water.
bulb. Fluorescent bulbs
He
can be
didn't
lit
release
from
how he did it though,
anything,
not on that post.
right?
You learned it from Mr. Angus
Okay.
Wangus.
This is the filament.
All right.
Oh,
It's an automotive
that's awesome.
filament bulbs, 12 volts,
Oh.
probably like 1 amp. Kind of strange. There's not much to that, right? All the way in the water. That shouldn't light at all, right? We should not have any light.
Like it should short circuit out the current and not ignite this bulb, right? Like that's
Absolutely.
I did
Should
not
blow
do
the
that.
breaker.
Nice noise. Yeah.
Hey, hold on. I paused it here and look at it's recording something shooting up from the spark gap that kind of looks like drips right now. But it's like little or something. It's so weird. But I actually recorded the same effect by my own Tesla coils one time.
See if you
here.
can slow it down. Like you can slow down the speed. Get to the point where you think it might be shown, and then slow down the speed on YouTube. Yeah, that's what I like to do. Get a nice slow look at it.
Good call. So
I was monitoring a
right in
UFO
this
that way. It
area.
was
Not have any light.
Hold on.
It sounded like they were mumbling and a big old fart came out.
When he pans back down right over the spark gap. Too slow.
Yeah, he should be like flailing if that was not cold electricity.
Here, yeah, right here, right.
Ugh.
See this? What's going on? Okay, so right in this area, right here, you'll see this like constant stream of things like shooting up, but sadly, it's like it doesn't really go into focus while he has it on.
Oh, I think I know what. Okay,
Right
go ahead.
here. So right here, you'll see it. Oh. Perfect.
Well, that's not
Right
it.
there. Right there.
By Ricky. Darn it, YouTuber.
I think I know what you're
Google
talking about.
/ alphabet. Hold on, yeah. Right there, right there.
Oh yeah.
You see
There
all
it
of
is.
that?
That's some kind of distortion. Yeah.
Yeah, right here. You see what I'm
It's
talking
a
about?
light. So there's a
Yeah.
light right there, and there's some kind of distortion
Water,
from the
all these
light,
things
like
Like it's almost like beads of water shooting up.
Okay, he's
Up
got a
there.
spark gap there, right?
what the heck is?
Yes, 100%. It's when the spark gap
Okay.
has the arc plasma go through.
And then the lights coming up from that, like
Yeah.
a bead of lights, like a string that goes straight up.
It's coming off of the spark gap. Look right here. The spark gap's right there. The spark gap's right there. It's shooting up off of
Oh,
the spark
yeah.
Oh,
gap.
pause
You
it
see what
right
I'm
there,
talking-
Bernie.
Oh yeah.
So there's like one here, one here, one here.
He's got
Yeah.
two spark gaps though. Didn't he?
Yeah.
Yeah,
I
he had a
guess
spark
there's
gap.
one.
That's some kind of
Yeah.
distortion.
Right, I
Yeah.
see it right there now.
You see what I'm
It's
talking
a
about?
light.
You see it shooting right here, right now, right?
Yeah.
Just a little bit before that, I think.
Yeah, it's hard to catch it.
Oh. Hold on, yeah. Yeah, he has to have it on. Right there, right there. Here it is.
Oh yeah.
You see all
What
of
is that?
that?
Some kind of distortion. Yeah.
You see what I'm
It's
talking
a
about?
light.
Yeah.
So there's a light right there, and there's some kind of distortion from the
All these
light,
things
like
up there, and it goes all the way
what
to
the
the
heck
top.
is that?
They're particles. It's coming off of the spark gap.
It's heat.
The spark gap's right there. Right the there? spark gap's right there. It's shooting up off of
Oh,
the spark
yeah.
gap.
Yeah, you can really see it if you know what you're looking for. I
That's
don't think
cool.
everybody sees it though. The little
Right,
piece
you
of
gotta
tape on
watch
the
a
bottom
weird
there,
anomaly, you know?
Yeah,
And
Is-
I
then,
see
Yeah, it is.
that.
where
and
it
you
comes
unplug
off of it.
and then it stopped. So it's coming from right
One
down
last
there at
time.
the spark gap, right here, right? There's the spark gap. It's
Yeah.
gonna come straight up here.
Yeah. And you see it in the camera, right?
Yeah.
Yeah. That I've
Moving
seen
straight
that
up.
many times
plasma.
before. It always is above a spark gap.
And then
But it's
yeah, it's
gotta be
always
cold
above a
spark
spark
gap.
gap. Always,
You know what
right?
though? When it's a hot one, I don't see it.
So I have an update.
So cold current, cold electricity or whatever here.
From my guess, yes.
Not medical advice. They are less lenient. I'm sorry, they are
Oh,
more
pause
lenient
that.
than YouTube.
Whatever he's saying there, pause
What?
that. Yeah, we don't need the volume on that.
Sorry, yeah, what Ben's saying. Sorry,
Yeah.
we'll let her play. And then as soon as this is like now he's putting an incandescent light in, and then it actually puts a plasma when it ignites, as opposed to like a yellow filament. And then you'll also see the same effect of the particles shooting up every time he turns it on.
It looked like, hold on, can you rewind it just a minute? It looked like the amount of energy in the bulb changed as he put his finger in there.
Yeah, good observation. You're absolutely right. Right? Boop, dips. Boop, dips.
Yep. You can see it filling up the light bulb and then coming back.
Hey, grounds it out almost, right?
Yeah.
I know what that's like.
It's like he's adding pressure to the system or more heat to the system, and it changes the system.
It's more
'Cause
heat.
yeah, cold electricity.
Yeah, but most people would
Yeah,
think of
we'll
it as
see
like
that.
you're grounding it out, but you're
And like,
essentially
look at how it's more of a plasma, like a white plasma-ish, than the yellow
That's
just filament. And now you can see right here, right? There's the anomaly.
yeah.
And each time he turns the bulb off or the circuit off, it instantly stops, obviously. But it plays one more time here in slow-mo, I think pretty good. And see, so the spark gap there is just the end of the two prongs of the power supply. Is that correct?
Mhm.
And I wish I could fix the resolution. It's the resolution of his camera. Right. Right there, you can see it a few. Right there.
Yeah. Same string of beads. I see
Right?
it
Like
all
it's
the time.
yeah, it's like a string of beads, right? Like
Yeah.
and
Something
it's
to do with the light. I think it was just regular tap water, King James.
yes.
What a name. That's funny.
Very strange. Very, very strange phenomenon.
I like it. I think it's awesome.
Me too.
Don't try this at home, folks.
Definitely, we do not endorse or recommend trying this at home. You will most likely end up dead. Don't do it. This is an anomaly that is not supposed to be happening. Like,
Yeah. I wonder what
The amount of
physicists
power that
say
would be
about
going
that.
in to fire that up.
Hey, I wonder what physicists say about that. You probably say it was faked. But even if they saw it right in front of them, I can't wonder.
Well, of course, because they don't understand the heat relationship.
Yeah.
It's a hard thing to understand, Gerald. You have to do the experiment to see it.
It's true. That is true. Yeah. I've done lots of experiments. Even then, I didn't see it. It took you to point it out. Right? So.
Why do we keep watching video games?
Hey, there's my ex. Oh, no. Sorry. I mean, that was after I broke up. No, I mean.
Sorry, that's the end of that. There we go.
There you go.
Oh, yeah. Oh, that's fun.
So yeah, I'm gonna have to bail here. I got some stuff I got to take care of, and
No
I don't know
worries.
if you'll be on later or if you're gonna keep going or what you're doing.
Yeah,
all good.
that 3 hours. Yeah. Well, what are you saying, Nathan? Do you want to go over
Yeah,
a little?
we can go a little longer if you want.
Nathan's going all day. He's making it a marathon. You know, I'll see you at 2 in the morning.
Oops, sorry, I didn't mean to do full
Get it.
screen.
If-
Come
If
on,
you're still on
come
after
on.
I'm done helping in the
There we
kitchen.
go.
sort of thing.
There we go.
Right on, Gerald. Thank you for coming in, man. Hopefully you're on later because we'll have some more fun.
Damn straight. Damn straight. I got a few
Absolutely.
things that hopefully we'll be able to show a little later. We'll see. All right. Thanks, guys. I'll talk to you soon.
Thanks, Gerald.
Thanks, everybody
No
out there.
So, Bernie, did you understand what I was saying earlier about this whole scaling?
Of the octaves
Yeah.
and the music, yes, absolutely. That's why I keep bringing this up. It's huge.
So, when I was talking about the cones and Victor was talking about the cones and getting the alignment correct and then put it in the correct octave,
Yep.
it was because the vortex on the top and bottom are creating this guy's chart. It's literally creating the octave chart right there in that vortex as it goes up and down. That's where it connects. And a lot of people, nobody I think ever mentioned it before I said it now. You know what I mean? How that connects into this whole ether thing and why it does.
Right, and it's all within Walter Russell's vortex-based periodic diagrams and systems, because it's like the universal law of mathematics. It's so much more, and people just think it's 1 or 2 chart. It's like there's literally 30, I believe, different octave periodic charts, like different scales using the octaves of plotting the periodic table of elements, and then also like thinking like hundreds of other just diagrams of energies with the vortex, the cones, and the displacement of in, out, negative, positive, in of the ether, right?
Yeah.
Creation, destruction. And so here's like first octave, second octave, third octave, again, of the periodic tables on the octave spirals. Like it's so beyond ahead of its time that like.
Well, so let's take it this way. The Anunnaki talked about putting gold back in, right? And how it fixed their atmosphere. Well, now you understand, looked on this table, if you put it in the vortex where it goes, they mined all the gold out of their planet, so they couldn't get it to put it into the vortex. So when you don't have it into the vortex, it conducts differently than every other element. So when Gerald shows his coil and he shows his gold and silver coil, he's getting different things coming out of it based on the energy that going through the gold itself. It produces a different field.
And here again, a complete another octave based scale geometry of the periodic tables, their charge differentials between them all on this octave, like mathematic geometric universal structure. And it has to do with the spin and the rotation.
That's
of
right.
Everything in the universe, right? Like,
Yeah, you have to align the vortexes in order to get it right. And once you align them, you're in the correct octave and you're in the correct tone. So, and then it puts you right in the right frequency to do it. You see the difference when you shift
right?
it like
That's
this?
how you get different isotopes, by being slightly off tone.
That's right. It's all one big circle. You just had to know where to put it.
This is the one big circle jerk of universal God and the creation of matter and antimatter from the ether and back.
That's right. It just keeps repeating itself.
Just keeps on circling around the galactic black white hole.
Oh man.
And the universal scaling and how they all just fit into each other. And when you use geometry with mathematics in an analog state, it's exponentially like smarter than we are today. Like it's wild. Just wild.
Oh, the upper picture, when you go back to it, Bernie, there's a reason why that inner cone is there.
This one?
Yep. You see the cone that goes off to the right and left from that, and it'll point to the center of the outside cue?
Yes, sir.
It's the same thing that Gerald was talking about when he put the flashlight in his coil. So if you take the coils on the outside and you spin a flashlight in there, right, it's going to refract. So it's going to break apart and create the center one that's larger, and then it'll go back out as you put the other one into it, right? So in the center, it makes that diamond shape that we're seeing here on that top picture.
Absolutely. And that's the focal points where you want to be able to have your reaction or your trigger, right, of what you're achieving.
That's why it's easier to see it as a diaphragm in the center than anything else. It comes to a point, but then the electricity itself pushes out from that point, and it creates that round sphere.
C is red, D is purple, E, oh no, C, oops, C is maybe more, there's this maroon, orange, E, F, orange, G, yellow, F, oh, F, A. I don't know music notes. I'm bad. I got to learn that.
But it tells you why they're in certain resonance states too, because you get the music and you understand music is resonance between two points, and then you get the sound that's coming out of both because it's like a speaker. So you're getting resonance between the top and the bottom when it's created in the sphere.
And right, the resonance is how when you're in that resonance state and then you get coherence with all the other atoms in the area, then that is how they're able to do these chemical reactions of transmutation at very low energy states and from sound.
It's the binding. It's what's binding them together.
Yes, exactly. Breaks and builds the binds and the phase shifts of it. And shout out last on Rumble.
Yeah, it's all right there. I just wish people knew it.
It's been hidden in plain sight for over 100 years and ridiculed and mocked by the establishment as woo. But when you really take a look at it, this was all drawn by hand over 100 years ago.
It's by the way, the different winds in your coils, it creates a different frequency in there. So when it does that, it creates a different sound. So it matters because two of them in resonance with each other is creating something different every time the geometry works. That's why you don't want it. So you can't cancel them out. You have to know where the points are, where they cross, so that you don't cancel them out unless you specifically want them to.
Harp Springs series number 3. Oh, we got another octave. Nurse line, the 9th, 10th, 7th, 8th octaves.
I wish these were in 3D, Bernie. It really give people an understanding better. You know what I mean? Maybe I should do that. We should get a preview program and put them in 3D.
We got to make an AI 3D version of all of this combined, or at least digital. Maybe not AI, maybe just through another program, but
AI is kind of hard because you put in something like this and tell them to put it in 3D, and you end up with something completely different.
Right, that's why I corrected myself on that. This is probably going to have to be organized by human programming hands, and anyone out there that wants to help with that, let us know. Here we have one of the Archway octave periodic tables by Walter Russell. Like, did you know that the periodic table could be arranged in an arch that's the same as on all the cathedral entrances around the world? And like, what? It's in the octave.
Well, they say that they built these things for the divine, and they did, but we misunderstood the answer.
6 octave working range.
It's also why they use pipe organ.
Are they going to try to cancel Walter Russell next because he has female and male labeling on his diagrams? Uh-oh. They're going to be like, geometry can't be sexualized. What do you
That's
mean?
so bad.
Magnetic flow.
Man, that Wayne guy isn't going to like it. That's for sure. Oh.
The cosmic pendulum. Interesting.
So hold on. I had one too. I was going to show it earlier. I didn't.
I was up doing videos all night, so I'm just tired and burnt out. You know, but as a Canadian, I might have smoked a little bit of marijuana, but no, sorry, this is not a kid-friendly show, but do not do drugs. Do not electrocute yourself, and wear proper safety equipment.
So check this out. This is more math that you actually need right here. When they start building their coils that look like this and you start seeing the shapes on the inside, then you see the mathematical formulas going around, you'll start to really understand it. Because 24 points, okay, winding the coil, how do you wind it? Why do you wind it that way? What are the fractals you're getting out of it? That's kind of, it's really important. So, and I don't want to say anymore because I don't want to give away Gerald's stuff, but this kind of stuff, when you start looking for something, that's what you want to look for.
But we want open source and to give away Gerald's secrets that Gerald doesn't give away.
No, he's got to give them out first.
This kid.
I can point you to the directions, but I can't give you the answer.
The inventor always. Respect to the inventor always.
That's right. So I can tell you though that it'll make certain tones based on which one you do it in a certain way. So if you break apart the each layer of the coil, you'll figure it out. So
Sandley the King would like a summary recap, please, Nathan.
yeah, well, what I plan to do, I'm going to put together everything I can to just put it into a video and actually make a long format video for it and do it that way, because there's a lot of visuals in there and you're going to have to see some of them because some of them will trip you out. Like when you start to see geometry put in 3D, it's completely different than what you have here. So I'll stop sharing that, Bernie. You pull up another one and I'll see if I can't find it real quick.
Okay. Hold on. Is this the right one? No. This one. Here we go. Is it gonna open? There we go. And buffering. There we go. Interpreting some ancient alchemical cosmic alphabets. Colors of consciousness. Here we go. Some interesting mathematics.
So I got one for you here, Bernie. Let me see. I might have to share the whole screen though.
That's more than fine.
It's,
yeah.
The geometry itself is putting off how the actual vortex is being built with the sound. Interesting, isn't it?
It is. I like this because this fits into like the Keshi coil windings essentially too that I've made, because they're like triple solenoid that I think would work in this style here that you are displaying. I just need to actually hook them up to the electronic aspects of the circuit, the amplifier, the power source, and the rest of it, right?
So watch this one. Is it showing up? You notice the geometry is showing you something different every time it moves.
That's the exact same as what Sheila Raman was getting. Lots of these quantum or these coherent geometries on her sonograph or whatever it is.
Yeah, it's the same shape. It's just how the energy moves through each part of it. That's why it's important to control the flow of energy and how it works. And then it creates different geometries. It's not just the original geometry that you put into the coil.
You're including all the different dimensional perspective flows and fields.
Yeah. Let me see if I can't find a better one that's got the pump. Because I don't know if it's going to be in here, but like this one's a good one that shows.
That reminds me of a rather famous Da Vinci drawing design, and a lot of his designs, his 2D designs, were actually 2D blueprints of 3D overbalanced and over unity wheels. Like it's crazy.
Yeah. So let's see if they got other ones in here. Man, there were a whole bunch of them you run into in here when you get to the right ones that are animated, they start to tell you something.
Oh, I love Pinterest.
Yeah, it's like the coolest thing, isn't it?
Days.
Let's see if they have it when you start looking at these.
Oh, that's kind of interesting.
Yeah, they got a bunch of different geometries in here. I'm trying to find the pump one, man. Those really tell you something. It has to do with vortex and pump.
Whoa, 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 whoa.
Yeah,
We love EDM.
I go over there and mute this thing. These things.
Trance techno house all day. Two, copy, strike away. Here we go. Dance, dance. Sorry.
So the one I was looking at earlier, it would actually show you the coil design, and then it would go into how it flowed.
What?
Yeah.
I can't find it. That sounds so cool.
Oh man, I wish I would have just saved it. It would have made my life a whole lot easier. Let's see. It's probably when you chase this rabbit hole.
We're chasing the interdimensional digital meta rabbit hole.
It's exactly what you're doing when you do this.
Have reached the end of the internet.
Yeah, like this when it shows you the dimensions here, and then it goes into how it's vortexing.
And ooh.
And then it shows you the actual shape of what you need to build.
Look at that. There's a few different sacred geometries in that right there. I like that.
So let's keep chasing that rabbit hole.
I want the interdimensional portal hole. But we got 3 holes, so there's one more. The small one that you wiggle it around in, I guess. That's what's left.
Oh man, you know what? I saved a bunch of them. I thought it recorded and it didn't.
Schizo wave, Bernie. Whatever. I gotta get into becoming a AI music artist, musician. If they call themselves that, I don't know. But yeah. So Jeremiah made some good stuff, actually, as has Ben.
Yeah, Ben was doing some good work too.
Where is Ben?
Yeah, and then Joe did that theme song. Did you ever listen to that?
I don't know. Maybe.
So here we go. We might get to it now yet. It's funny because you know which one's if you look at these mandalas when they do them, you could tell the energy flow from the how you build it based on the dimension on the curvature of how they do it. Man, we're chasing this rabbit hole deep and it's still not giving me what I want.
We're in between the 2 and 3 dimensional, but it's a digital fractal while simultaneously being.
So this right here, this is a better representation of what's going on in a sine wave.
Really?
So it's pinching and then it comes out from the pinch. So when you get the pinch, you get heat. And then when it comes out of the pinch, it goes into a higher frequency and a higher amount of voltage. So that right there would be 10 times better than what your oscilloscope shows.
Well, that looks like the ultimate rainbow lasagna noodle, whatever the heck the one theory is. But the perfect waveform. Yeah.
Yeah, I'm not finding it, man. I don't know why.
It doesn't want to be found today.
Yeah, well, I was watching it earlier, man. I do this thing and I go back and I record it. Maybe it's got to be on one of these. That's going in the wrong.
John. Much love. Sorry, Nathan, just in respect for Sean Calderon taking off, we're going to play a quick goodbye tune for Sean.
I'm a pineapple. 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 I'm sweet. I got a beat. Just look at me. What do you see? Pineapple. I'm a 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 pineapple. I'm sweet. I got a beat. Just look at me. What do you see? Pineapple. I'm a pineapple. Pineapple. I'm a pineapple. Pineapple.
All right. But yeah, shout out to Paranoid American Thomas, who made that video. He's actually really good with the AI art, both music and graphics. And I gotta bring Thomas back on with you guys because he'd be the perfect one to help us make a couple renderings and models of some of this stuff.
Oh, have you ever seen this, Bernie? I'll show you this one. So, that's the wrong one.
Oh yeah,
Does it stop?
there we go. Keeps going.
That's so cool. Doesn't have anything to do with what we're talking about, but it's so cool.
It absolutely does. It's folding back into itself. It's that's one of the motions of the toroid flow.
That's so cool.
It's absolute. Like, is that how you materialize in and out of the ether? Maybe. I don't know.
Oh man.
Bob Lazar likes it. Probably got to do with element 116.
Is that the real Bob Lazar?
Definitely no. But you never know. I'm going to say yes. I approve. It's Bob Lazar.
Oh man.
This one. So I don't know about the claims specifically of each frequency, but these are the solfeggios. So do you mess around with putting these into your coils in Graviflyer at all?
Let's see.
Oh, we got the AliExpress Bob Lazar. Don't give Bob Lazar your credit card info, okay? Jeez, we got AliExpress Bob Lazar. Watch out, ladies and gentlemen, and everyone in between.
Oh man. Yeah, these frequencies are far too low.
Oh, but what if you amplify them with...
I could put the Tesla coil down to those frequencies, and we can see what we can do.
And then
I know you never heard of that, huh?
Each other.
So when you add a mass to the center of your Tesla coil, you bring down the frequency. So I can get it, as lowest I got was 20 hertz. So, and it resonates normally at 730, and I dropped it down to 20 hertz.
Okay.
So we'll have to do some testing to see if we can't get it to say 432, and we'll take the tuning fork out, put it down in the center, and see if we can get it to ring.
Yes. That I want to be a part of. And then get one ringing over here at the same time. The complexity of vortex geometry.
Yeah, it's like a study into itself. It's cool.
And we want to be these guys with their flying halo portal thing wings, right?
Yeah, well, they showed you the thing right there. They showed you the two fields you have to interact.
Break
The
it
one on the
down for
bottom?
us.
You see it? You have to create
Yeah.
the two fields, and they have to interact.
Oh, I see what's going on here.
Light as a feather. Static electricity, light as a feather.
Okay, that's where that was coming in.
So it's like when you take the static electricity experiments they did in the 1800s, and then
Yeah.
they held their hand up and they put the paper under it. The paper would become saturated and it'd lift.
Yep. Absolutely.
I wish people would have paid more attention to that experiment instead of writing math.
There's flying vehicles out there. These people are probably still flying out there too. What do you make of these?
You ever see some of these on the okay, you ever watch those UFO stories and they show you these symbols that are on the side?
Yes, sir.
That's what they remind me of.
Good call on that. And why does Taku here look so much like the Star Trek logo?
But it makes you wonder too. It's like that little pitchfork you see there, and then they use it as a sign in geometry, or not geometry, but in not algebra. What is it? Come on, Nathan. One of them. Anyway, they use a bunch of these things in there, and then they show them like this, so it makes you wonder if we're actually building the craft.
Sorry, just had to take a phone call there for a minute. Right? But like that's deep, Nathan. It's like what if because these are legit alchemical sigils of angel and demons, I think. Like, so what if it's literally an angel or a demon that is in those crafts that have these sigils potentially written on the outside, right? Like,
What if I told you that the church hid all the geometries from you so that you wouldn't learn the answer, and then they called them like pagan symbols, or they turned around and they call them
13th or 666 Satan and all the
That's
rest
right.
of it? Yeah. Well,
they told it all to hide it from you so you'd never look into it.
100%.
The church is not always your friend, man.
Especially when they're like molesting children and their grandparents, and it's just horrible.
Oh, go back one.
Oh, yes.
Did you see Sean's go back one from that? Right there. This is exactly what Sean was describing with his round Tesla coil, the energy being produced.
Sean, you pieced out 5 minutes too soon, bro, but I checked mark, made a stamp here, so we'll edit it for you later. And hey, shout out V Sears watching now.
Hey, what's up, V? Anytime he wants to come on, I'll shoot him an invite, man. I love it when he comes on, man.
Me too.
Let me pull that up. He said he had a computer situation going on, so he couldn't come on the last couple times, but we'll see if he fixed it.
Right? They're very finicky. It's like, are we under attack and we're just paranoid, or just do our computers suck?
You know what it is?
But
My graphics card hates two monitors. It absolutely starts freezing everything, and then like StreamYard hates the fact that I have two of the same webcam, and it starts to glitch out there. So
gotcha. So that's essentially probably the exact same problem I'm facing.
yeah,
Would make
It's like-
sense.
it makes you want to run two computers just to get it right, so you could show both of them. You know.
It really does.
By the way, V Sears, I sent you an email. If you can come on, I gave you the invite. Yeah, they were talking about, what do you think on this, Bernie, with the wave as a light, and then is it a photon or is it not a photon? Or is it something more?
It is, and it's definitely something more, because it's also a wave, a light, a plasma, and possibly even a crystal.
Really?
Is it time? Does it have time within it? That's a good question.
I don't think light shows itself until the energy is being used. So it goes
I
to
think a lot of what Jack Sarfati said was complete BS, and I had to bite my tongue on him talking shit about all of that and so much different stuff. And I'm waiting, to have the opportunity to discuss it all, hopefully with David Rossi, Ashton Forbes, and Sal Pius at some time in the future, to bring up so many different discrepancies and why there needs to be a debate, and that what's really going on behind the scenes most likely is that Sarfati is actually fighting for, Sal Pius for the actual patent of the super force in the physics and engineering world, and is just being extremely dirty and wrong about his approach with it. But I'm not going to get into it.
What's the super force? Is that like the super team? What's
it's
going
like
on there?
bias effect, and it's what Sarfati is trying to call the Sarfati force, but Pius originally called the super force. It's like the God equation, I think, essentially.
No, they're fighting over math.
They're fighting over the math of the God equation.
Okay.
They're trying to name it after themselves, and thus it should just be the S force, the super force of God. So maybe just G, the G force, the real G force, the big G force. I don't know. Universal G force. All right. I'm going to shut up on that.
So did you not jump in because Jeremy was there interviewing him, or what?
Well, see, so actually, Jeremy had kind of taken me off guard there, as we had been planning a stream that I was like late for. Like, I was supposed to start like the very beginning of it with him, but it was supposed to be on weather manipulation, and we were gonna talk about like Hurricane Helene, like the earthquake machines. Antarctica. I was going to bring up a lot of like Dutch census work, as well as Eric Hecker's go deep into it and then apply it to like the latest stuff. And like it was all Jeremy's idea, and he'd been like planning it with me all day. And then it was like I run 10 minutes later. It's like I was stoked he started the clip or the show off with the David Rossi Sal Pius note, because it's like I had sent that to him the week before. I was like, yo, check this out. Like, try to get him to play it on the last stream we did. Anyways, played it at the beginning of this one, and then Jack was there, and I was like, all right, well, we're going. I love, I love and hate the Jack, because I love Jack Sarfati for like the legend and intelligence he is, but I hate the schmuck CIA fuck that definitely resides within that guy. So it's like you don't know what's the agenda is, because there's always going to be multiple of them from him, because literally, like as Gerald was saying, like he was part of like the science CIA science team of MK Ultra. So like for all we know, he could have been like running the MK Ultra. Like who knows what
Wow.
Jack Sarfati really knows and has done. But the fact of the matter is he has definitely done a lot and definitely knows a shit ton. So you always have him on, but I try to be as unbiased as possible, but I also try to like, you know, challenge him as much as possible without like triggering him to like, you know, feel disrespected, because the guy is old and a legend and, you know, is giving us her time, but simultaneously he's got his CIA agendas. So it's like you try to feel him out to try to get what his narrative is and what he's all saying and stuff like that. But like one of the great things is like I pressed him on Iran, Israel several times, and like he's like a American Jewish physicist, and I got him straight up on his own saying that Iran is not the enemy, our own government is, and they're the ones pushing us to war. So it's like, you know, it's like he's speaking from the heart there. So not all that he says is BS, but regardless, it's interesting. Or is he just a CIA operative trying to create rebellion and a civil war psyop? I don't know. Like, but
I don't know. I think Iran's government's the enemy, but I don't think its people are. That's for sure.
exactly, right?
They just want some fighting over religion again.
And how many trips to Epstein Island did he make should be the question. That is a legitimate question. But I can tell you, if he truly was a creep, because he's in New York and he had no idea who the fuck P. Diddy is or Sean Combs, so it's like Epstein been out for a while. If you were into that sort of thing, you'd probably be hooked up with the new one. And since he had no idea who that guy is, I'm gonna give him the benefit of the doubt. Just saying.
Check his closet for baby oil. That's what you're saying?
Yeah, right. Jack, you don't need 10,000 liters of baby oil for this warp drive experiment. I'm just kidding. I don't know.
Oh my God.
Cancel me.
I love it when they come out with that stuff, because it's a whole load of crap, man. Oh,
Right?
we're taking this bubble and we're taking on this flat plane and we're going like this to the bubble, right? Well, how did you get the flat plane? Because I've never seen a flat plane in space at all. Where did it come from? Was it the magic carpet ride you were on? Because I've seen a lot of flat planes on those carpet rides. You know what I mean? But never in reality.
Right?
Oh my God.
It's so far-fetched.
I only got through like 15 minutes of it when watch your show, man. Because it was like, if you dump on a freaking garage guy again, dude, it's like, I'm just going to blast you, dude, because I've about had it. It was like, talk down to everybody, and you're not talking.
Like I said, it was amazing and synchronistic. It was a true think tank that you had put out, Star Trek Fringe Tank episode 3, Bernie's Bad Mushroom Trip, because literally, it was literally the third time I'd probably done mushrooms in like the last 12 months for sure. And like it was a micro dose, like, and the reason why was the second time I had done them in the last year was like the past weekend at my father-in-law's funeral, when one of my brother-in-law's friends gave us a few mushrooms to microdose. So I had one left and I just had randomly taken it in the morning, and then you put that out and I was like, oh, this is amazing. And then I was like, oh my God, interview with Jack Sarfati. This is gonna be a fun guy of a time. And well, that's what happened.
Oh my God, dude, that's too much. So you were on your personal own trip.
or all of that is just in the role-playing action fantasy non-reality of the metaverse. Yes. Okay.
There you go. Oh man. Oh, that's so funny, man. On the trip of your own while watching another trip, that's got to be a trip. You know what I mean? The whole
Triple
complexity of
tripping,
it.
man. I was triple tripping, bro. 3 holes. 3 holes.
It probably never left your head at that day, man.
Triple tripping on the 3 holes.
Oh,
Okay.
that was so great,
right.
man.
Okay.
Oh,
What was I gonna show? This one. More to the musical tones and octave scaling and
nice.
the importance of it in the fields. Oh, maybe this is not what I thought that was. My bad. Oh. Alchemist's alphabet. Interesting. H is Mercury. Weird. And Saturn. What? Strange.
It's
But
funny
then this different.
the way they write them. It changes the meaning of them
Absolutely.
because they're all supposed to be the same thing all the way across, right? Is that the way this
Supposedly.
works?
I think so, but it's rather confusing, right? Like, or is this B all the way? Like, what? No, this is, I'm confused. Because here you have gold and here you have gold. Here it's A, here it's E. But it's A, E, maybe? Like,
I was
here
looking
we
at
got
something that had alchemy in it.
69. Got Cancer, but you have Mercury, but you have Saturn. Very strange indeed. Potentially a cipher or different languages. It got gold again at O. I swear many of these symbols, these pictographic alchemical symbols, are of energy vector based like diagram of what they're representing, like whether it be chemistry circuit, a reaction, an element, different minerals, if that makes sense.
Well, hold on. I got one to show you, Bernie. Tell me what you think of it, okay?
100%. Okay.
So it shows you the heavenly bodies, right? And then it goes on to start telling you about different things. And it all has to do with the shapes that you put into things.
Okay. I'm following.
So I was just wondering what you thought of it, because it was
Crucial.
complete oddball to me.
It has to do with the charge and like the electro and magnetic like charge and capacity of each of the metals, like iron, copper, gold, silver, and then the position of that corresponding heavenly body at the time that you're doing it, sort of thing. Like, so gold, you're going to get more energy out of during the day while the sun is up. Silver, you're going to get more during the full moon. And like the copper, iron, and lead, stuff like tin, being like Jupiter, Saturn, Mercury, obviously, but Venus, Mars, and that I honestly believe, and it also has to come do a bit with Ed Leeds Scallon at Coral Castle was also huge into this and applying it to what he was doing, and put it a bit in the, not his first Sweet 16 book, but one of his later book publishings on magnetism.
I just
But
thought it was interesting.
it is, and there's so much more to it. And I know I sound like an absolute raving lunatic in that, like, making all these wild claims, but it comes down to, for instance, why the different domes or roofs of like the cathedrals and churches and places of worship, they all have the alchemical symbols, and then the alchemical symbol that they have on them is the corresponding metal that they then cover that dome or piece with, and they're built with these astrological alignments to the actual planets and heavenly bodies. So it's like, it seems that they are somehow harvesting or using or tying their energy technology into it with this stuff. It's very, very complex, wild, and the alchemist's rabbit hole for another day.
Well, it might be that the use of energy when the sun's out and how it affects the ground is different. You know what I mean?
Yes, exactly. The grounding aspect of it, the sun, and then think casting spells, and that's a huge part of them all, and their sigils and what they're doing. So then that, well, where the heavenly bodies are, where the sun and the moon are, and their cycles while they're doing their rituals in these specific geometries that they do in their spell circle. And I don't know, I'm very aware of like the witch and Wiccan and alchemical stuff and the sigils and all of that.
So hold on. So if they're standing on, say they take the star on the left, right? And they stand on each one of the corners and they make the sound one right after the other.
Yes,
is that
exactly.
like a flow direction?
Yes, exactly. You got
Okay.
it. So yes, and then there has to be like 4 or 5 of them in it to complete the cipher or the whatever it's the witches or Wiccans call it. But yes, you got it full on. And then when they're doing it at those center focal points, for instance, in those dome building, cathedral amplifying places, in the alignments of per se the solstice or equinox or eclipses and all of that, then you're getting exponential amplification on the energy that they're doing or casting.
It all pretty much makes sense to what we're doing now. I don't know if you noticed that they're telling you the flow direction and then which people are singing in the direction, and then how to acoustically put it together. It's not much different than what we're talking about in these coils.
Right? So that's the next thing is you're going to have to go take your gravifier and try and fire it off in a cathedral and see what happens then while the organs play.
I gave Jeremiah a giant clue on how that thing works. I'll see if he spreads a word to his buddies over there at Falcon and see if they actually use it. So, and I don't even know if he picked up on what I told him, but we'll see. See if it comes out some other way.
He's probably pondering it right now and the implications into his own abilities to test and make the next version, right? Like
Well,
like I said, we will see.
you have to understand what I said. I'll leave it at that. No reason to go back into it. It's just, it's like giving away the secret to the whole
secret
thing.
sauce. You gave away some secret sauce in this stream earlier. For all those,
I
wanting to
just,
know it.
I guess deep down, I hope it gets to the right person so they understand what mistake was going on. So,
Right, and that's the whole point of letting it drip out in open source, open mic, Saturday Fringe Science Think Tank.
I don't want to be the only one that does this. You know what I mean?
Wizardology. Boom! Who else wants to be a wizard?
You see a lizard?
Teaching that secret sauce, y'all.
Oh man.
All right. Well, I guess we're almost at 4 hours. Anything else you want to cover, or?
You know what? We show the shape. I can't show the motion on those shapes. I wanted to today. That would have really put it in perspective. So, yeah, Victor, I sent you an email. If you can come on, I hope you got your computer fixed. Let's see. Yeah, I wanted to show a couple more of those, if you don't mind, Bernie.
Oh, by all means, this is your show, brother.
Well, you're on it, so
Try and stop you, Nathan.
We'll just do a little Star Trek here for a minute, so I can laugh a couple more times.
Oh hell yeah, I'm Trekkie for life.
So we'll just start at the beginning. Oh. I got to do the next one, man. It's going to be hilarious. All right. Mike, this is the captain speaking. Have you and Ben been able to fix the transporter yet?
That's what I'm saying. I can explain to you very simply how to verify if that ground, the third prong at the bottom, the circle hole. I think it's 3 prongs, right? 3 holes. You're in Canada? I don't know.
No. It's 3 holes. Yeah. It should be.
So you have the ground. The third hole is the ground. So you could test that ground by. You have the 2 other holes. Are they the same size or is one bigger?
I'm sorry. Say that again.
You have a third.
All right, say that again.
Ground at the bottom.
One of your holes
Either
bigger.
at the top or the power. Are they
Yes.
the 2 holes? Are they the same size?
Your 2 holes are the
One
same size.
bigger.
No. They're the same size.
It's one
Same
hole
size, so
looser
it's
than
2.
the other, guys.
You're in Canada.
He keeps asking if you're in Canada.
Ben, are
So
you
it
in
can't
Canada?
be the same size. One slit is a little shorter.
Are you sure? Let me see.
Look closely. You need more light in there.
Oh yeah, you're right.
I'm sorry, Mike. Did you say you had the transporter fixed?
Put the voltmeter on AC 120 volt setting. Put one prong in the ground and the other prong in the smaller hole. That's your hot line. And if you get 120 volts, that ground is working good. If you don't, if you get less than 120 volts, like 90 or 80, your ground is probably no good on that plug. That could cause a lot of issues for the circuit too, by the way.
Well, the problem is this only goes up to 10 amps and then it blows.
No,
so-
you don't need amps. You just need 120 volts is what it should read.
Okay.
Oh,
As long as it doesn't blow my fuse.
Put it
I'm
on
good.
volts, not amps, volts. 120 AC volts.
This should be good to 250 volts. So we should be okay.
hey, Gerald, come here and listen to this. I can't tell if they're fixing the transporter or not.
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one, the smaller.
Does it matter which one is which?
That's a tough question. It kind of does matter. But anyway,
Wait, so okay, so the red
of the two holes, other than the ground hole, of the two holes that you have there, one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
the negative. Okay.
Yeah, you
so-
don't want to use that to.
All
check
right,
your
so
ground. You wanna
real
check
quick
the
before I
power.
electrocute myself, Mike, which
You're not
which
going to.
hole do I stick this in?
Don't stick the probe out. Just stick the
If
prong.
the hole is
Oh my
red, there's
God.
something wrong.
The probe has two prongs, two metal.
I'm sorry.
You
This
put one
one got
prong in
really
the ground and the other prong in the smaller of the two holes that are left.
but it doesn't matter which
Put
one
it
is
in the
which.
smaller of two holes and wiggle it around.
No, it does. One of the probes, you have two probes from the voltmeter. One goes, no, it doesn't matter which one of the two goes in the ground. No, it doesn't.
Okay, so I
Bringing
can
up
put the
probes.
black one in the ground and then
Yeah.
the red one in the
Yeah.
small slot.
Yes. Sorry, I
Okay.
misunderstood you there.
No, it's okay. We're talking about putting things in holes.
Yeah, easy to get confused.
Mike prefers a certain one.
It's easy
So yeah, if you
to
don't
get
see a 120
confused with
volts right
putting
away,
things
just
in
wiggle it
holes,
around till you
ladies
get a
and
good
gentlemen.
connection. You should see either 120 volts or like less than that, like maybe
It's just
100
too
volts.
easy.
Yeah, 120.
Well, especially
your ground is
when
good. You
you're
just
electrically
verified it.
engineering the
It's good
Star
ground.
Trek Enterprise.
Now, just so you know, if it read less than 120, like around 100 or 90 or 80, that ground is
for
no
New
good.
Hope.
Right. Okay. It was actually slightly above 120. So is that normal?
Yeah, you're
It's like
good, you're good.
120.3.
The ground
okay.
is good. Good. Just make sure you're
Oh.
firmly connected to that third prong into your circuit.
Something tells me we're never getting this transporter fixed.
If you were to put one prong into ground and the other prong into the return, you wouldn't get anything because it's not source. You're not hitting source. You want to go from ground
Oh
to,
my
from
God.
source to ground to get a reading.
Oh,
No, that makes sense. If you're getting if
Oh.
it's not properly grounded, you're going to be getting a loss.
You're right, Nathan?
yeah. I'm living right now. I'm barely breathing. Oh,
I'm wiping tears over here. I'm telling you, that was the best.
Mike's best segment ever. I swear.
That was awesome.
I've given her all she's got, Captain.
I like you are a genius in this. Like we couldn't have a better captain. We couldn't have a better Star Trek captain for the Fringe Tank think tank. And shout out Sean Terran Earthling. You did arrive late, but if you're up for doing your presentation, if you want to do some right now, I can send you the link. Would be a perfect time, I think.
What has he got going on?
A bunch of electrogravitics and all the patents for it. It is literally right up your alley, Nathan.
Hmm.
And it's
Yeah, as
something
long
that
as he
you-
can pull it up. Yeah. Oh, hold on. I'll play another episode where we figure that out. Oh,
Yes, please. and I
trans-
will be right back.
people of planet Dreamscape, greetings from the Starship Fringe Think Tank.
Welcome to the Plant Dreamscape.
It's an honor to meet you, Gold Lady. We'll be transporting down to the surface in no time.
I must warn you, Captain. Any random thought during transport may have unexpected consequences.
Gerald, gather the away team and meet me in the transporter room. Guys, try to be on your best behavior. That Gold Lady seems like one of those uptight scientist types.
The elite of the most prestigious scientific communities.
Gerald, I don't think that Gold Lady's going to like that.
There you go.
Well, when it comes to women, as me dear departed father used to say, you can't live with them, and marrying's illegal.
You know, there was something I was supposed to remind you guys about. Something about random thoughts. Huh? Oh, well, we'll just figure it out when we get there. All right, Ian, 5 to transport.
Nathan. Oh my God.
This didn't work out for us at all. Oh, man. Have you guys seen Bernie?
All right.
It's gonna be so great.
Ben, where was Mike? Isn't he usually running the transporter?
Right. So now put one prong in the ground, the other prong in the smaller hole, not the bigger one, the smaller.
Does it matter which one is which?
You know, that's a tough question. It kind of does matter. But anyway.
Wait, so okay, so the red
Of the two holes, other than the ground hole, of the two holes that you have there, the one is smaller. That is the smaller hole is the power. The bigger hole is the return for that power.
the negative. Okay.
Yeah, you
so-
don't want to use that.
Oh my God. That's so funny, man. Oh, I got two more if you guys want to see them, man. Absolutely hilarious. Let's take Bernie's trip down memory lane for the. Oh man, I pushed the wrong button. Captain speaking. Joe, can you please report to the transporter room? We need to go back to the planet where you found your strange rock. Bernie's going to meet us down there. Mike, transport us down.
You have three holes. One is ground at the bottom, and the two that are at the top are the power. Are they the two holes? Are they the same size, or is one bigger? Put one prong in the ground and the other prong in the smaller hole. That's your hotline.
Is he daydreaming again? Hey, Mike, transport us down to the surface, please. Okay, Joe, where exactly did you find this strange rock?
And I could sense it. So I'm very attuned to it. I could sense it as soon as I start fumbling around with it. I'm like, up there it is, you know.
Well, let's keep moving down the river to the cave where Bernie is. Oh man, look at all these magic mushrooms.
All right.
Joe, have you ever eaten any of these things?
Psychologically, you know, having high amounts of that crap around wasn't the best for me. You know, it would, you know, always kind of grab me, and I'm like, oh yeah, all right, that, you know, and this kind of did that, and it was very, very intense, and it wasn't bad.
Well, after careful consideration, I say we eat some of this stuff and see what happens.
Wow. Instant brain fart there.
Are we still in the cave? Why is everything moving? What's going on, guys?
Direct departure. You know, the 90% of the brainwashed most senior epic legends and pillars.
What the hell did he just say? Oh my God, I'm tripping balls, man.
You know, I'm deep into meditation, you know, and you know, some different spiritual aspects and stuff like that of you know, metaphysics. And you know, I could tell you, I mean, these things, they do have, you know, psychological effect, you know, as far as that stuff goes. And
My lips aren't moving, but I'm still talking. Must be an inner monologue. Awesome. We want to turn it on. We want those effects. We want our mind to work the machine. You know what I mean?
Mm-hmm.
So we can figure out how exactly to do it.
Spinning the rotation aspect, that is now one dynamic of open system adding to it.
so it's like, oh, well, I mean, what's the difference? It's like, because things don't do this.
Yeah, that's why.
That's why. You see, like, yeah, it's subtle. You're running your finger across something and you're feeling it starting to skip on the surface, but it's smooth. You know,
Yeah.
It's like, things don't do this, and this does this. And yes, it's subtle, but it's there. You know, but then there's the more extreme examples, you know, like the thing, you know, taking a lift off, you know, and it's like it just slipped out of your hand.
Oh my God. I can hear Joe in my head and Bernie in my head, but their lips aren't moving.
And then
Which
it's like, so you
isn't
add that
at all.
You know, you
spinning
push it this way, it
to
goes that way.
other
You push it this way,
aspects,
it
like
goes that
bringing
way,
in
and
radiant
then the thing
energy
isn't going to
from the
exert
environment,
its own
like if it's
force
endothermic
out
cooling
of my
or
hand
from a
that you
plasma,
can
right? All
feel
these
on your
other
hand.
aspects that
You
you
know,
start
like,
combining those
Hertz was
dynamics
doing
of extra energy
was forced
in
down
that
like a
you're
sack of
able to
potatoes
get the
to the ground.
exponential gains
and I
in your
couldn't move.
systems.
You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes. You have 3 holes.
Oh my God. There's no more holes. There's no more holes. There's no more holes. Mike, beam us up.
You're right, Nathan?
Yeah, I'm living right now. I'm barely breathing. Oh my God. Well, now I see, you see what I do with my free time over there, making these videos, man. Oh, yeah. Just having fun with the guys, man. I always find something in the stream that we talk about, add it into a little Star Trek episode and have some fun. Oh man. Kind of makes it easier, man. Everybody gets in here and talks about serious stuff, you know what I mean? We always do, but got to have the lighter fun side of life, man. So anyway, I just thought that was pretty cool. I'll end up doing another one, especially with the material from today, man. So awesome. So I don't know where Bernie went, man. Got some cool stuff in there, though. See all kinds of paintings and stuff. Electrochemicals going on in the background. Anyway. Yeah, I think we're pretty much done for the day for now. Looks like everybody's got something going on. So, all right, guys. I want to thank you guys all for showing up and hanging out with us and seeing what's going on, man. Yeah. So we'll hit it up tomorrow with Joe. We're going to be talking about left side, right side of the brain is what he told me. So it's going to be an interesting show. We get into some theory and some theoretics around it. But I think it's going to be awesome. So, yeah, 10 o'clock tomorrow morning. If you want to hang out for a few hours with us, we'll be back on then. All right, guys, thank you for showing up. Have a great day. And I'll see you later, Bernie.